Sir, please start the program. I request our coordinator, Dr. Pankaj Kumar Das sir, to start.
Okay. Okay, thank you, Mosumi. A very good afternoon to everyone present in this session. So today, this is the last day of this 6 days online faculty development program of Atal Academy sponsored by AICT. And everybody knows that this thrust area is in advanced material, rare earth and critical minerals. And the title of our FDP is Revolutionizing Construction with Sustainable Advanced Material. So I welcome all the participants as well as our expert to this first session of day 6, which will be delivered by the presentation will be delivered by our speaker, our guest, engineer Sam Sundar Mishra sir, on the topic advancements and forthcoming innovations in sustainable construction. Before that, I want to introduce myself. I am Dr. Pankaj Kumar Das, Head of the Department of Civil Engineering, Synergy Institute of Technology, Bhubaneswar, and the coordinator of this program. And my co-coordinator is Mrs. Mosumi Mahapatra, Assistant Professor of Civil Engineering Department. At the outset, again, I welcome you, sir, to our first session. Engineer Shamsundur Misra is the regional head, Technical Customer Solution Odisha at Ultratech Cement Limited, an Aditya Birla Group of company. He has completed his bachelor's degree in engineering from BPUT Odisha, and he has 26 years of effective experience in multiple industries, both in construction as well as techno marketing, and expert in 3D home architect deluxe application. He has field experience in Associated Cement Companies (SCC) for about 7 years, and he has working experience in L&T construction for 4 years. He has construction experience under East Coast Railway for around 2 years, and Engineer Misra has been working under the brand of Ultratech from 2011 to till date. He also has a keen interest in Vastu advisory. Engineer Misra loves to travel with his own car and bike. So I welcome you, sir, to our session, and I wish this session a grand success. Again, I welcome you and request you to start the session, sir.
Thank you so much, sir, for a fantastic, actually, introduction. It is not necessary for me, actually. I hope I am audible to all of you.
Yes, sir, you are audible. And I want to say a few words before that. Actually, sir is suffering from fever, and at this condition also, he's agreed to deliver the talk. So definitely, I salute you, sir, and welcome you to start the session, sir.
Thank you so much, Pankaj sir, for the support and for this media to connect with this audience. Before starting this session, let me understand who are the audience actually. All are from Odisha or outside Odisha?
Maximum number of candidates from Odisha, and
Okay,
all are faculties. This is a faculty development
faculties.
program,
Okay.
and faculties are
Yes,
attending this program.
yes. So before going to the topic, our most and measurable impact on a word, sustainability. While we are talking about sustainability, are we doing something sustainable? My question to all the audience. Are we doing really? Because where sustainable word will come if we go for a greener construction, then it will be sustainable. So th- this is my question, open question to all of the audience. तो मुझे ये जानकारी थोड़ा आपसे चाहिए कि आर यू सीरियसली adopting green construction? बोथ वे कम्युनिकेशन होना चाहिए इसमें। एक्चुअली ये सेशन वन साइड में होगा तो डिजिटली नॉर्मली क्या होता है, कनेक्ट करके मोबाइल पे या पीसी पे कहीं पे छोड़ जाते हैं, तो ये सही नहीं रहता है। तो बोथ वे कुछ ना कुछ अगर आप चार्ट में रेस्पॉन्ड देंगे या फिर आपका ऑडियो ओपन करके रेस्पॉन्ड देंगे तो उसमें अच्छा लगेगा। यस प्लीज। जगन्नाथ जी, आप कुछ बोलना चाहते हैं? चैट में कुछ रेस्पॉन्स, स्लाइड्स आर नॉट चेंजिंग राइट। मैंने अभी तक टॉपिक स्टार्ट नहीं किया है, तो टॉपिक स्टार्ट नहीं हुआ है तो स्लाइड चेंज होने की बात ही नहीं है। तो मेरा अभी क्वेश्चन आपके आपके साथ है, आर वी गोइंग फॉर ए ग्रीनर कंस्ट्रक्शन रियली?
No, sir, not really. It's not greener construction. Totally, it's not greener construction, sir.
So for a greener construction, actually what point we need to look into?
So we should go for steps that are including protection of environment, but totally 100% we have not implementing it. That is why it's not done, sir.
वेरी वेरी ट्रूली सेड। जहाँ पे सस्टेनेबिलिटी की बात आती है वहां पे आता है एनवायरनमेंट की बात, वहां पे आता है रिसोर्स की बात, वहां पे आता है सोशल रेस्पॉन्सिबिलिटी की बात। तो ग्रीन कंस्ट्रक्शन, कोई भी ग्रीन जम बनाते हैं, चाहे वो रोड्स हो, ब्रिज हो, होम हो, या छोटा सा भी कुछ भी बनाते हैं, कोई भी स्ट्रक्चर, तो आज की डेट में आप देखेंगे ग्रीन बिल्डिंग काउंसिल के वेबसाइट पे जाके आपको बहुत सारे प्रोडक्ट जो कि ग्रीन प्रो सर्टिफाइड मिलेगा। वो ग्रीन प्रो किस बेसिस पे सर्टिफाइड है वो उसमें मैंडेटरी किया गया है पॉइंट्स के हिसाब से। दूसरा चीज, जहाँ पे हम कंस्ट्रक्शन कर रहे हैं वहां पे एनवायरमेंटल इम्पैक्ट क्या आ रहा है, टेम्परेचर का क्या आ रहा है, विंड्स का क्या आ रहा है, देन रिसोर्सेज का क्या आ रहा है। अभी बहुत सारे पॉइंट्स इसमें कवर होंगे। तो मौसमी, रिक्वेस्ट टू चेंज द स्लाइड, नेक्स्ट स्लाइड। तो आप जब आज ए गार्डियन, बिकॉज ऑल ऑफ यू आर फैकल्टी, आज ए गार्डियन जब आप अपने बच्चों के लिए कोई भी मकान बनाएंगे, सबसे महत्वपूर्ण बात क्या है? उस घर में जो रहे हेल्दी रहे, हैप्पी रहे। ये हेल्दी और हैप्पीनेस की बात कहाँ से आती है? अगर इंडोर एयर क्वालिटी अच्छा हो। ये कैसे होगा? नेचुरल लाइट, नेचुरल वेंटिलेशन और टॉप सॉइल प्रिजर्वेशन, नेचुरल रिसोर्सेस, ये सबको हम जब एक साथ जोड़ेंगे तभी जाके हेल्थ एंड वेलबींग का इम्पैक्ट आएगा, नहीं तो नहीं है। आप उड़ीसा का एक सदर्न पार्ट में जाइए, आपको मिलेगा एक डिफरेंट स्टाइल ऑफ होम कंस्ट्रक्शन। उनको ओपनिंग नहीं चाहिए घर में, डोर हो गया इनफ। तो उस तरह का अगर कंस्ट्रक्शन करेंगे, ये खाली हेल्थ के इम्पैक्ट नहीं आता है, ये इवन इफ आपको मेडिकली इतना नेगेटिव इम्पैक्ट मेडिकली कर देता है। आप जितना इनकम करेंगे ना, वो हेल्थ हेल्थ के टुवर्ड्स वो एक्सपेंसेस चलता ही जाएगा। तो आज के डेट में ये सबसे बड़ा महत्वपूर्ण चीज हो गया है कि शुरू से हम कैसे अपना घर को ग्रीन होम कर सकते हैं। तो ग्रीन होम करने के लिए ये नॉर्मली जो 5 चीजें यहाँ पे मेंशन हुई है, आप देख सकते हैं। जस्ट ए मिनट, लेट मी। यूज ऑफ इको फ्रेंडली मटेरियल, देन फोकस्ड ऑन एनर्जी एंड वाटर सेविंग्स। सबसे मोस्ट इम्पोर्टेंट फैक्टर है कॉस्ट, कॉस्ट एंड टाइम सेविंग। आई थिंक यहाँ आज से पहले भी आपने सेशन अटेंड किया होगा कुछ लेटेस्ट बिल्डिंग मटेरियल्स के ऊपर, जो आज की डेट में रेडी टू यूज। जैसे आप घर में बैटर बनाते हैं, बैटर बनाने के लिए टाइम लगता है, सब इंग्रेडिएंट अलग अलग लगता है, लेकिन आज की डेट में रेडी टू यूज मिल जाता है। आप कोई भी मॉल में जाइए, रेडी टू यूज बैटर मिल जाएगा। वैसे भी बहुत सारा मटेरियल आज की डेट में अवेलेबल है मार्केट में, जिसमें कम पानी लगता है, कंस्ट्रक्शन फास्टर होता है और बेहतर होता है। तो ये सब चाहिए तो आपको ये 5 चीजों पर ध्यान देना होगा। नेक्स्ट प्लीज। भागीरथी जी, आप कुछ बोलना चाहते हैं?
नो सर, नो सर।
ओके, नेक्स्ट। तो आज कॉर्पोरेट सोशियली रेस्पॉन्सिबल ऑर्गेनाइजेशन आदित्य बिरला ग्रुप, आपको पता है ये फॉर्च्यून 500 का कॉन्ग्लोमरेट है। तो अल्ट्राटेक इज पार्ट ऑफ इट। तो आज के डेट में आप देखेंगे तो ये वर्ल्ड का लार्जेस्ट सीमेंट मैन्युफैक्चरर है एंड बिल्डिंग सॉल्यूशन प्रोवाइडर है। तो हमारा ये रिस्पॉन्सिबिलिटी बनता है कि हम कैसे कस्टमर को, चाहे वो छोटा हो या बड़ा कस्टमर हो, स्मॉल बायर हो या लार्ज बायर हो, उसको कैसे शुरू से हम गाइड कर सकते हैं ग्रीन कंस्ट्रक्शन के लिए। ये एक हमारा छोटा प्रयास है जो लास्ट 2 साल से, 2 साल से नहीं, 3 साल से हम धीरे धीरे ग्रीन होम के ऊपर ज्यादा फोकस कर रहे हैं, जो कि नॉर्मली एक मतलब बीपीएल कैटेगरी के लेवल का अगर कोई भी आदमी घर बना रहा है, उसको ग्रीन होम का कुछ फर्क नहीं पड़ता है। बट लेटर ऑन धीरे धीरे जब घर एक्सपांड होता है, बड़ा होता है, धीरे धीरे उसका इम्पैक्ट पता चलता है। फिर इसको बुलाओ, उसको बुलाओ, वास्तु को बुलाओ, कुछ खराब है, ये सब बहुत सारे चीज नेगेटिविटी फिर क्रिएटिव होता है। तो हम ज्यादातर 3 एस के ऊपर फोकस करते हैं, सेविंग, सस्टेनेबिलिटी एंड सेफ्टी एंड हेल्थ। ये तीनों चीज को नजर में रखते हुए हमने ये डिसीजन लिया कि कैसे ग्रीन होम कंस्ट्रक्शन को हम आगे ले सकते हैं। नेक्स्ट प्लीज। ये कुछ पैरामीटर्स है जो ग्रीन होम रेटिंग्स के लिए सर्टिफाइड किया गया है कि दीज आर द मैंडेटरी नॉर्म्स, जिसमें क्रॉस वेंटिलेशन से लेके लोकल बाइलॉज, टॉप सोइल प्रिजर्वेशन, देन सेटबैक्स, फ्रंट रियर बोथ साइड, देन लैंडस्केप में कितना वेजिटेशन है। यहाँ पे क्वेश्चन आ सकता है, मैं मान लो भुवनेश्वर में घर बना रहा हूँ, मेरा 1500 स्क्वायर फीट का प्लॉट है, मैं अगर ग्रीन होम के ऊपर फोकस करूंगा तो मेरा घर कितना बनेगा? बन सकता है आराम से। हम लोग जो सर्टिफिकेशंस प्रोवाइड करते हैं आईजीबीसी के थ्रू, इंडियन ग्रीन बिल्डिंग काउंसिल के थ्रू, नेस्ट एंड नेस्ट प्लस। नेस्ट जो है 1500 स्क्वायर फीट तक का प्लॉट एरिया जो है वो नेस्ट कैटेगरी में आता है, और नेस्ट प्लस जो है मोर देन 1500 एंड लेस देन 3000 स्क्वायर फीट, वो आता है नेस्ट प्लस कैटेगरी में। इसमें भी हम ग्रीन होम सर्टिफिकेशंस करते हैं कुछ पॉइंट्स को देके। सर्टिफिकेशंस के लिए मिनिमम 30 पॉइंट चाहिए, लेकिन उसके ऊपर रेटिंग्स अगर चाहिए, सिल्वर या गोल्ड, प्लैटिनम, डायमंड जो भी है, तो उसके लिए फिर अलग अलग लेवल का पॉइंट लगता है। तो दीज आर सिस्टम्स। और प्लम्बिंग, सैनिटेशन, देन आपका वाटर सप्लाई, जो भी ये सिस्टम जितना भी आप एडजस्ट लगा रहे हो, तो सभी के ऊपर ये बेस करके ये पॉइंट्स अब डिसाइड किया गया है। इवन इफ रेन वाटर हार्वेस्टिंग, सोलर सोलर एनर्जी, आप अगर एसी का इंडोर यूनिट बिठा रहे हो तो आउटडोर में कितना उसका फ्लो जा रहा है, ये सब सब पॉइंट्स इसमें कवर होता है। और आजकल आपको पता होगा कि म्युनिसिपैलिटी जो वेस्ट लेता है घर से कलेक्ट करके, ड्राई अलग लेता है, वेट अलग लेता है। ग्रीन होम का ये भी एक क्राइटेरिया है कि आपको वेस्ट सेग्रीगेशन करके भी रखना जरूरी है हेल्थ के लिए। नेक्स्ट प्लीज। 3 स्टेज पे हम इसको गाइड करते हैं, एक होम प्लानिंग स्टेज, कंस्ट्रक्शन स्टेज, देन फिनिशिंग स्टेज। ये स्टेज बाय स्टेज हम जाएंगे। नेक्स्ट प्लीज। आप देख सकते हैं स्टेज 1 प्लानिंग स्टेज में हम कहाँ कहाँ इसको शुरू से कवर अप कर सकते हैं। एक तो लोकल बाइलॉ जो है, आप अगर सेटबैक में कुछ जगह छोड़ रहे हो वहां पे भी आप लगा सकते हैं, या फिर इंडोर प्लांट भी आप लगा सकते हैं। देन सनसेट एंड चाजा एंड क्रॉस वेंटिलेशंस, आपको उसी हिसाब से डिजाइन करना पड़ेगा स्टार्टिंग से घर को। इधर सिविल इंजीनियर के हिसाब से आप खुद कर सकते हैं, या फिर कोई आर्किटेक्ट की मदद लेके भी कर सकते हैं। नेक्स्ट। लोकल बायलॉज ये आप लोगों को पता है, इसके ऊपर मैं ज़्यादा नहीं ध्यान दे रहा हूँ, क्योंकि बायलॉज हर म्यूनसिपैलिटी कॉरपोरेशन या डेवलपमेंट अथॉरिटी का फिक्स्ड रहता है, उसी बेसिस पे उन्हीं का कंस्ट्रक्शन का वो निर्माण वो डिसाइड करते हैं, और प्लान अप्रूवल उसी हिसाब से होता है। तो ये सेटबैक्स डिसाइड करना है किस साइड कितना आपको छोड़ना है, ये मैंडेटरी है। बायलॉज नॉर्मली कुछ कुछ जगह पे आप देखे होंगे वो रूल्स को फॉलो नहीं करते हैं, लेकिन नॉर्मली दिस इज ए पार्ट ऑफ दिस एक्सरसाइज। नेक्स्ट। ऑलरेडी मैंने ये कवर किया है। नेक्स्ट प्लीज। जो लैंडस्केप वेजिटेशन की बात मैं बोल रहा था, आप चाहे लैंडस्केप कुछ भी कर सकते हैं आप, लेकिन इसमें सबसे मोस्ट इम्पोर्टेंट है टॉप सॉइल प्रिजर्वेशन। आप जहाँ पे घर बना रहे हैं, एक्सकावेशन होने के बाद नॉर्मली क्या होता है, इधर वो सॉइल्स को दूसरा जगह यूज करते हैं, या फिर सैंड में उसको कन्वर्ट कर देते हैं, लेकिन उसको प्रिजर्वेशन दैट इज ए पार्ट ऑफ दिस एक्सरसाइज। हेलो। नेक्स्ट। चाचा क्यों चाहिए, सनसेट एंड चाचा क्यों चाहिए नॉर्मली, कोई बता सकता है? आजकल
So,
मॉडर्न जितना घर पर, हाँ बोलिए।
so for protection from rainwater and
डायरेक्ट सनलाइट,
yes, sir.
लेकिन आजकल मॉडर्न स्ट्रक्चर जो बन रहा है ये सब अवॉइड कर रहे हैं। आपने देखा होगा बहुत सारे बिल्डिंग्स बन रही है, कमर्शियल्स बन रहा है या फिर रेसिडेंशियल्स भी बन रहा है जिसमें ये सब अवॉइड कर रहे हैं। अवॉइड इन द सेंस वो लोग डिजाइन में कुछ मॉडिफिकेशन करते हैं। नॉर्मली डोर विंडो जहाँ पे है वो कन्वर्ट कर देते हैं बालकोनी को वहाँ पे। तो ये बहुत काम करता है। डायरेक्ट सनलाइट जैसे घर के अंदर ना आए, सनलाइट का इफेक्ट आपको पता होगा। नॉर्मली मॉर्निंग आवर में जो लाइट से आता है, अर्ली मॉर्निंग हम वॉक करते हैं, किस लिए करते हैं? पंकज सर आप भी वॉक करते हैं ना?
नहीं सर, मॉर्निंग सनलाइट से विटामिन डी मिलता है।
विटामिन डी मिलता है, लेकिन अगर वही सेम वॉक हम 12 बजे के बाद करें, क्या मिलता है उसमें?
So ultraviolet, sir.
यस, एग्जैक्टली, अल्ट्रा वायलेट रे, जिसका बहुत गहरा इम्पैक्ट है ह्यूमन शरीर के ऊपर, चाहे वो ह्यूमन हो या फिर एनिमल्स हो, जो भी। तो वो बहुत ही नेगेटिव इम्पैक्ट होता है। तो उसी हिसाब से हमारा प्लानिंग रहना चाहिए, जैसा डायरेक्ट जो अल्ट्रा वायलेट रे घर के अंदर ज्यादा ना फैले। लेकिन अल्ट्रा वायलेट रे एक जगह इम्पोर्टेंट है, वो है वॉशरूम या बाथरूम। वहां पे अगर आता है तो ठीक है, पोजीशनिंग ठीक है ना। इसीलिए तो आप देखे होंगे ना, वास्तु में बताया जाता है कि आइदर वेस्ट और नॉर्थ वेस्ट, इस पार्ट में आप लोग टॉयलेट कीजिए, क्योंकि वही एक पोजीशन है जहां पे उसको सफिशिएंट अल्ट्रावायलेट रे मिलेगा, बैक्टीरिया इन्फेक्शन ये सब नहीं रहेगा वहां पे। वो पोजीशनिंग वास्तु के हिसाब से वो किया गया है, उस हिसाब से। नेक्स्ट। ओके ओके ओके। क्रॉस वेंटिलेशन, व्हाई इट इज इम्पोर्टेंट? कैन एनीवन से व्हाई इट इज इम्पोर्टेंट क्रॉस वेंटिलेशन? एनी गेस? मैं आपको यहाँ पे हिंट भी दे दिया हूँ।
Sir, for air circulation, sir.
और एयर सर्कुलेशन, ओके। तो मान लीजिए आपका एक रूम में ओपनिंग से साउथ साइड में, लेकिन उसका विंडो है आपका ईस्टर्न पार्ट में, वो, और एक ऑपोजिट में आपका नॉर्थ पार्ट में डोर है। उस घर में एयर जो सर्कुलेशन रहेगा पॉजिटिव रहेगा या नेगेटिव रहेगा, कुछ आइडिया है?
सर प्लीज रिपीट।
एक स्मॉल एग्जांपल दिया। मान लीजिए एक छोटा सा रूम जिसमें साउथ साइड डोर है, ईस्ट पार्ट में विंडो है, और साउथ का ऑपोजिट, एग्जैक्टली ऑपोजिट नहीं है, वन कॉर्नर नॉर्थ साइड में डोर है। तो वो जो रूम का क्रॉस वेंटिलेशन सही रहेगा क्या? सिंपल क्वेश्चन।
नहीं सर, वेंटिलेशन नहीं हो पाएगा, प्रॉपर नहीं
बिल्कुल
हो
सही,
पाएगा।
बिल्कुल सही बोले, लेकिन कारण बता सकते हैं Can you share why it is negative?
There is no cross ventilation because the positions of windows and doors are not in right way, in the right position.
Okay.
They are not front to front.
Normally, ventilation comes throughout the year, almost approximately 8 to 9 months from south part, and particularly in winter, it 3 months max to max 4 months. It comes from northern part. So cross ventilation means it should not be either direct straight. तो ये जो इंक्लिनेशन है टोटल बिल्डिंग का, आपने जब स्टार्ट किया लेआउट किया, उसका कितना डिग्री इंक्लिनेशन है ईस्ट वेस्ट नॉर्थ साउथ के हिसाब से आपको डोर विंडो की पोजीशनिंग भी उसी हिसाब से डिजाइन करना है, ताकि अगर नॉर्दर्न पार्ट की वेंटिलेशन जितना घर के अंदर फैला है उतना घर के लिए अच्छा है, लेकिन साउदर्न पार्ट की अगर वेंटिलेशन के अंदर हमेशा चलता रहेगा तो मोस्ट ऑफ दी केसेस देखा गया है कि जितना सारा फैमिली मेंबर्स है सबका स्किन डिजीज रहेगा। इसीलिए अगर दक्षिण की हवा, साउथ की अगर हवा घर में जाती है तो उसको बाहर निकलने के लिए एक रास्ता चाहिए। उड़िया में कुछ कहावत है, मुझे एग्जैक्टली अभी पता नहीं चल, मैंने याद नहीं आ रहा है, कुछ दक्षिण दरवाजा ऐसा कुछ वो वाला कहावत है, कोई बता सकता है क्या? वही एक रीजन है। तो उसी हिसाब से वो वास्तु इज नथिंग, वास्तु इज साइंटिफिकली प्रूव, बट इन सम केसेस वी हैव टू रेस्ट्रिक्ट अकॉर्डिंगली। डायरेक्शन कोई बोल दिया कि एग्जैक्टली आपका ईस्टर्न फेसिंग का घर है, रियली साइड पे वो ये है क्या? एज ए इंजीनियर वी हैव टू चेक। अगर साइड पे हमको पता चला कि 45 डिग्री इंक्लिनेशन है ये या 30 इंक्लिनेशन है, तो उसी हिसाब से हमारा विंडो पोजीशनिंग डोर पोजीशनिंग चेंज हो जाएगा। नेक्स्ट प्लीज। नेक्स्ट। आप लोगों में से कितने लोगों के घर में ये हुआ है? दिल से हाथ रख के चैट बॉक्स में यस लिखिए। अभी तक कुछ नहीं आया रिस्पॉन्स। भागीरथी त्रिपाठी यस। बाकी just see, we are engineers, but even we have not done this small things, rainwater harvesting. घर कितना बनता है? मैक्सिमम 2000, 2500, 3000 स्क्वायर फीट का घर बनाते हैं। अगर ये छोटा सा काम कर देना, छत की ऊपर जितना रेन वाटर, उसको अगर प्रिजर्व करने के लिए हम उसको प्रॉपर चैनल कर दे, कितना खर्चा आएगा? ज्यादा से ज्यादा 20,000 रुपया। तो अगर आप यहाँ से देख देख लीजिए, जस्ट सी, out of 75 76 crowds, so I only see 2 yes rainwater harvesting they have done. Just imagine your ₹20। 3 साल के बाद क्या होगा? दिसंबर में ड्राई होके नदी पड़ा हुआ है अभी,
हेलो सर।
अप्रैल में तो बाकी है, जून बाकी है।
गुड आफ्टरनून सर।
Yes, good afternoon.
Sir, I just want to ask, what should be the opening direction of the windows? Should it be north-south is well, or northeast is well, or northwest is well, or southeast is well, or southwest is well, or straight ventilation is well? So what should be the norm for ventilation and lighting?
Initially, what sentence you have used, I could not listen it actually because of some network issue. Can you repeat?
I just want to say, if network issue is still there, I just want to say that what kind of ventilation we should have in our building.
Northern ventilation is well good for all the inhabitants for
That you told, but if
uh,
we will have northern opening, so air will not infiltrate into the room, because there should be another side opening, so to passage for the passage of the wind, air. Only northern opening is not sufficient. Either we have along with northern opening, we should have also southern opening or east opening or west opening. So
both side it will be there, both side it will be there, but you have to think for the positive part. मैंने क्या
acha,
बोला?
will it be good if I will have north and south openings in a building? Will it be good? Straight north and south straight openings. Suppose I have
Your
open space towards north and open space towards south in my building. Suppose I have
yes,
open
yes,
space
yes,
towards
yes.
north
Yes, it is
and
good. Yes, it is good. But in the eastern part, whether you have setbacks,
eastern. Suppose I have I have freedom to open any side. So suppose I have restriction. I have opening on north side, but I have restriction to open on south side. So I left is only east and west. So which side will be better? Along with north opening, which side will be better, east or west?
always north, east, these are the positive sides. But जहाँ पे ऑप्शन
Okay.
नहीं है, you can go for south part, but always avoid western part.
Yes. Okay, okay. So northwest will be a very good option. North, suppose I will be have
Yes,
opening on north as well as suppose in
yes,
I have a particular room and I will have north opening as well as south opening. Sorry, north opening as well as east opening. That will be better and good also.
yes, yes, yes. That will
Okay,
be
sir.
positive impact on the
Positive impact.
all the inhabitants.
Hmm. So yes. So if there is some restriction in south and east, then can I have north and west? That means
South में
perpendicular
restriction
ventilation.
नहीं. Can you specify कि what exactly you want?
नहीं मैं बोलना चाहता हूँ कि अगर मेरे नॉर्थ तो ठीक है, नॉर्थ तो अच्छा है, नॉर्थ ओपनिंग है, साउथ अगर रेस्ट्रिक्शन है तो मेरे दो साइड रह जाता है, ईस्ट एंड वेस्ट। आपने कहा कि ईस्ट चाहिए, अगर मेरे साउथ भी
नहीं
रेस्ट्रिक्शन
था.
है, ईस्ट भी रेस्ट्रिक्शन है,
मैंने
ओनली पॉसिबिलिटी वेस्ट है, तो मैं वेस्ट में ओपनिंग रखूं या ना रखूं?
वेस्ट में आप ओपनिंग रखेंगे, कम रखेंगे. ऐसा नहीं कि
क्योंकि
वेस्ट,
ओपनिंग
क्योंकि
अगर नहीं
वेस्ट में
रखेंगे
आपको,
तो वेंटिलेशन ही नहीं होगा। ओपनिंग अगर
हाँ
नहीं
आपको
रखेंगे तो एयर आएगा ही नहीं।
वेस्टर्न वेस्टर्न पार्ट में रखना पड़ेगा, लेकिन वो डिपेंड करता है आपका प्लॉट का एंगल के हिसाब से, कितना एंगल वो डेविएट करता है उसी हिसाब से रखना है, और मिनिमाइज करके रखना है. मिनिमाइज इन द सेंस आपका जो बाथरूम है, तो बाथरूम का जो साइजेस के हिसाब से विंडो लगता है वो इस हिसाब से लगेगा. अगर कुछ डाइनिंग है तो
दैट
डाइनिंग
इज
का
वन
मेन
पार्ट।
पर्पज वहां पे आपको लाइटिंग पर्पज चाहिए. वेस्ट पार्ट से कोई वेंटिलेशन आता नहीं नॉर्मली, साउथ वेस्ट से आता है, लेकिन वेस्ट से कुछ नहीं आता है.
यस यस। एंड रिगार्डिंग सनलाइट,
Always eastern part is good.
ईस्टर्न पार्ट इज गुड।
Yes.
The sun also comes to west after
If,
noon. In the afternoon, it
हाँ,
comes to the west part.
मैंने क्लियरली बोला कि मिनिमाइज करो. वेस्टर्न पार्ट में ऐसा नहीं कि पूरा बंद करके रख दो,
Okay.
चाहिए.
Okay.
मिनिमाइज करना है, जितना
Hmm.
लाइट चाहिए
Oh, yes,
पॉजिटिव
yes.
के लिए. आप वैसे देखिए ना, कोई भी कमर्शियल स्ट्रक्चर बनता है चारों तरफ ग्लास ही ग्लास लगता है।
हाँ
ग्लास
हाँ
क्यों
हाँ
लगता है? क्यों? ग्लास इज ग्रीनर मटेरियल। उसमें एक कोटिंग रहता है जो डायरेक्ट सनलाइट को अंदर आने नहीं देता है।
जी
वेराइटीज ऑफ ग्लासेस आर देयर। तो केसेस टू केस, यही
सर सर
एक पॉइंट है जहां पे आपको सोचना, बीइंग ए सिविल इंजीनियर, यहाँ पे आपका कंसर्न रहना चाहिए कि मैंने अपना नेक्स्ट
हाँ
जनरेशन के लिए कितना पानी बचाया है।
सस्टेनेबिलिटी, सस्टेनेबल डेवलपमेंट।
अभी जो यस, तो
हम्म
नाउ एक पानी का बोतल वी आर परचेजिंग एट द कॉस्ट ऑफ 20 रुपीज, मे बी आफ्टर 3 or 4 years इट विल बी 30, 40, बियॉन्ड 10 years it will cost around 100 rupees.
at the during 1995, while I graduated from my engineering institute, while I went to Delhi, so their water bottle was 25 paisa, and I was hesitating to purchase. So why should I will purchase water to drink, even if I was not paying 25 paisa, and I am coming to home by walking and drinking water at my home. 25 paisa I was not spending in
Yes,
1995. Now I am spending 20 rupees per bottle.
yes, just see, it is a real example. So we
This is
need to
my
think
case.
on it. We need to think on it. एक फैमिली में सपोज वी आर न्यूक्लियर फैमिली अगर है तो 5 मेंबर या 10 मेंबर हम रहते हैं मेड को मिला के, तो
Hmm.
एटलीस्ट डेली कंजप्शन के हिसाब से, पर कैपिटा कंजप्शन के हिसाब से हम लोग का इतना वाटर जा रहा है डेली, तो कितना
Hmm.
बचा रहे हैं हम? वी हैव टू
जी
कैलकुलेट अकॉर्डिंग।
हम्म।
तो आई थिंक एवरीवन शुड वर्क ऑन दिस। कुछ
यस
लोगों को मैं चाहूंगा कि आप ये एक प्रोजेक्ट के तौर पे आप लीजिए, अपना जो भी है, इधर आपका कॉलेज हो या आपका खुद का घर हो, आपको एक प्रोजेक्ट के तौर पे इसको डिसीजन लीजिए और इम्प्लीमेंट कीजिए प्लीज।
rain water harvesting is a must nowadays. Without water harvesting plan, there should not be any approval for the construction of the building.
फिर भी उड़ीसा में हो जाता है।
हाँ उड़ीसा में हो जा रहा है, उड़ीसा में हो जा रहा है, बट दैट शुड नॉट बी। रेन वाटर हार्वेस्टिंग एंड इंडिविजुअल वेस्ट वाटर डिस्पोजल सिस्टम, दैट मस्ट बी मैंडेटरी।
Yes, 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 there are bylaws also, but nobody is following. Government have a scheme on rainwater harvesting that is called chhata scheme, but how many of people are taking the profit from it?
We are not concerned, we are very little aware of sustainable development.
We are not concerned. This is a right, not a right sentence. We are concerned, but we are not taking it seriously.
Yes, we know everything.
Yes. So that's why we have taken this challenge to implement. क्योंकि आज ये ऑर्गेनाइजेशन, ये हम लोग का डिसीजन है, कुछ हटके करना चाहिए। नॉर्मली देयर आर सो मेनी कंपनीज, व्हाई अल्ट्राटेक? इट शुड
Yes.
हैव सम डिफरेंट काइंड ऑफ इनिशिएटिव। नेक्स्ट प्लीज। ये प्लानिंग स्टेज में हमने ये सब कवर करके देखेंगे। ये मैंने शेयर किया है सबको। आप चाहे तो ये अपने घर का आप खुद रेटिंग कर सकते हैं। आप देखिए इसमें कहाँ पे आपको टिक मार्क करना है, कहाँ पे आपको क्रॉस मार्क करना है। उसी हिसाब से आप अपना घर को आज ए प्रोजेक्ट के तौर पे लीजिए या फिर कॉलेज को आज ए प्रोजेक्ट के तौर पे लीजिए और ये डेवलप कीजिए। नेक्स्ट प्लीज।
Okay, sir. Thank you.
देन ग्रीन बिल्डिंग मटेरियल आज की डेट में मार्केट में ऑलमोस्ट 90% मटेरियल जो अवेलेबल है, क्योंकि सभी कंपनी धीरे धीरे सस्टेनेबिलिटी पार्ट के ऊपर अभी अपना फोकस कर रहे हैं। तो उसी हिसाब से मटेरियल का भी मैन्युफैक्चरिंग टेक्नोलॉजी से लेके उसका डिफरेंट पैरामीटर्स चेंज होता रहा है। तो आईजीबीसी के वेबसाइट पे ये आपको पूरा मिल जाएगा, व्हाट आर द ग्रीन बिल्डिंग मटेरियल्स ऑल। एक्चुअली आप अगर कोई भी फर्नीचर खरीद रहे हो, वो फर्नीचर ग्रीन प्रो सर्टिफाइड है कि नहीं वो भी पता चलेगा। नेक्स्ट, मौसमी नेक्स्ट। और ये एडिशनल और एक पॉइंट है, आपने रेन वाटर सपोज यूज कर लिया, सेटबैक्स प्रॉपरली ले लिया, टॉप सोइल प्रिजर्वेशन ले लिया, लेकिन और भी एक डिसएडवांटेजेस है जो घर में अगर कोई भी आप टॉप फ्लोर में रहते हैं, आपको पता होगा टॉप फ्लोर में नॉर्मली टेम्परेचर इफेक्ट कितना रहता है। अगर बाहर छत की सरफेस टेम्परेचर 45 डिग्री है तो अंदर की सरफेस टेम्परेचर भी वही लगभग 42, 43, 44 डिग्री के आसपास भी रहता है। तो उसको कैसे हम कम कर सकते हैं, दैट इज ऑल्सो कम्स अंडर ग्रीन बिल्डिंग सर्टिफिकेशन पार्ट। तो कैसे करेंगे, अगर कुछ रिफ्लेक्टिव कोटिंग उसके ऊपर कर देंगे छत के ऊपर। तो अगर अल्ट्राटेक की बात करें, अल्ट्राटेक हब सॉल्यूशंस ऑफ टॉप सील्ड जो वाटरप्रूफ की भी काम करता है और सरफेस टेम्परेचर को 10 डिग्री तक भी माइनस कर देता है। तो ये वन टाइम वाटरप्रूफिंग सॉल्यूशन है पूरा घर के लिए, और घर का भी जो टेम्परेचर वाला इशू था वो भी दूर दूर कर दिया। तो बोथ दी वे यहाँ पे वो अवेलेबल है। तो ये हर स्लाइड में आप देख रहे होंगे यूटेक इज द प्लेटफॉर्म जहाँ पे कोई भी इसका बेनिफिट ले सकता है। आप भी ले सकते हो, आपकी फ्रेंड्स रिलेटिव्स भी ले सकते हैं, कोई भी ले सकता है। दिस इज फॉर ऑल ओवर द वर्ल्ड ये प्लेटफॉर्म बनाया गया है। तो ये मोबाइल से ऑपरेटेड एप्लीकेशन है। तो ये एप्लीकेशन के थ्रू जाके आप कुछ ना कुछ जो भी सर्विसेज आपको चाहिए जहां भी चाहिए, वी हैव डेडिकेटेड एप्लीकेटर्स, वी हैव डेडिकेटेड एक्सपर्ट इंजीनियर्स ऑल्सो, जो आपको गाइड करेंगे ये कैसे बेटर हो सकता है और उसका ड्यूरेबिलिटी पर्पज को नजर। नेक्स्ट, नेक्स्ट जो भी देखेंगे आप, इवन कंक्रीट, नॉर्मली आप कंक्रीट इज ग्रीन प्रो सर्टिफाइड, ये सुनने में आपको थोड़ा एस्टोनिश्ड लग रहा होगा, लेकिन आज के डेट में दिस इज ऑल्सो पॉसिबल। मोदी जी का टारगेट नेट जीरो का कब तक है, कोई बता सकता है? नेट जीरो इंडिया। आप लोग नेट जीरो की मतलब समझते हैं ना, नेट जीरो? am I audible?
Yes, sir. Yes, sir. You are audible.
So actually I am not getting any response from the audience actually.
Audi-
Anyone, can you
Audience are
tell what?
listening to you, sir. Audience are listening to you only.
I need both way communication actually.
So audience are requested to communicate with sir.
Can someone tell what is net zero of India?
So it's actually having 0% greenhouse gas emission from one product. So
नहीं, आई एम आस्किंग फॉर इंडिया नेट जीरो। मोदी जी का कुछ मिशन है ना, कब तक वो नेट जीरो करेंगे इंडिया को? इसीलिए अभी धीरे धीरे सभी गाड़ी चेंज हो रहा है, बाइक्स कार सब चेंज हो रहा है, ईवी अभी गाड़ी आ रहा है धीरे धीरे। गाड़ी का सब मॉडल्स, इंजन मॉडल्स वो भी चेंज हो रहा है। तो कुछ गवर्नमेंट ने मिशन लिया है, वैसे नितिन गडकरी जो सेंट्रल मिनिस्टर है, जितना नेशनल हाईवे बनता है उसमें भी वो उन्होंने टारगेट रखा है नेट जीरो का।
Hello, sir. May I speak?
यस प्लीज।
Sir, myself, Vaishali Bogar from Government College of Engineering, Karad. That Honorable Prime Minister's mission is to achieve by 2070 a net zero mission, as per my information. Is it
यस
correct?
यस यस, यू आर एब्सोल्युटली राइट, बट डू यू नो व्हाट इज द टारगेट फॉर अस नेट जीरो?
Means carbon emission should be nullified,
यस
reduced. And
यस,
that's
दैट
why
इज
electric vehicles are launched and
फॉर
slowly switching over from these all burnings, carbon emission.
एब्सोल्युटली राइट।
So slowly we are heading towards that.
यस
Other using renewable sources of energy, we are now
बट
guided to use.
हाँ, you are right.
Yes, sir.
Enter Aditya Birla Group targeted net zero by 2047। 2047 हमारा टारगेट है नेट जीरो करने का।
After
जितना
100.
सारा डेवलप हो रहा है, हम अभी भी आप देखोगे हमारा R&D में जितना डेवलप हो रहा है नेट जीरो के लिए, वो सब उसी मिशन को नजर में रखते हुए कर रहे हैं। अभी अल्ट्राटेक में जितना गाड़ियां भी अभी एंगेज हो रहा है ना, सभी ईवी है, ईवी व्हीकल्स। हाँ, नेक्स्ट प्लीज। ग्रीन बिल्डिंग प्रोडक्ट कैटेगरी में ही मुझे डिटेल में कुछ बोलना नहीं पड़ेगा, बिकॉज ऑल आर सिविल इंजीनियर्स। तो जो नेचुरल रिसोर्सेस से उसको मैक्सिमम कैसे बचा सकते हैं, बचा के, और लोकली अवेलेबल मटेरियल जो है उसको कैसे यूटिलाइज कर सकते हैं, उसी के ऊपर ज्यादा फोकस करना है। नेक्स्ट। पहले बोला है ऑलरेडी, लैंडस्केपिंग पर्पस के लिए ये टॉप सॉइल प्रिजर्वेशन इट इज मोस्ट इम्पोर्टेंट। तो इसको कहीं बाहर फेंकना नहीं है, इसको यूज करना है वही ये के अंदर। नेक्स्ट। मैंने ऑलरेडी बोला है ये चीज, फिर if you are going to do it with concrete, there are also concrete decorative solutions also that we have also. Light con concrete, decor concrete, I-floor concrete. There are lot many concrete solutions we have, depending upon the site condition, depending upon the stage of construction, depending upon the type of soil, we are designing it also. Decorative purpose, we can also use it. Next. इसको रीयूज कैसे करना है रेन वाटर को? आप इसको चाहे तो आप अपना ग्राउंड वाटर टेबल को रिचार्ज करने के लिए भी छोड़ सकते हैं, या फिर कहीं कहीं से पीट से इसको फिर से रिकनेक्ट करके आप यू कैन यूज इट फॉर वेजिटेशन पर्पज ऑल्सो। यस राधेश्याम, एनीथिंग यू वांट टू ऐड? Radheshyam, you want to add something? Okay. Next, please. वॉल्स के ऊपर आई थिंक मुझे बोलने की कोई जरूरत नहीं है, क्योंकि ऑल आर फैकल्टीज, आप लोग स्टूडेंट की कैरियर बना रहे हो, तो आपने बहुत सारा बॉन्ड तो बताया होगा, इंग्लिश बॉन्ड, फ्लेमिश बॉन्ड, तो वो तो था पुराना वाला, लेकिन आज की डेट में देयर आर लॉट मेनी blocks are coming, ASC blocks are even are coming. So how can we use it efficiently? That we have to look into also. Next. So similar type of exercise, just a planning, during home planning you have done. During home construction also you can check it. तो क्या क्या हमने काम किया है, क्या क्या नहीं किया है, ये एक एग्जाम्पल के तौर पे मैंने यहाँ पे दिखाया है। तो अगर नहीं किया है तो उस हिसाब से आपको यू हैव टू टेक द एक्शंस। नेक्स्ट। देन फाइनल स्टेज फिनिशिंग। फिनिशिंग के टाइम पे आपको एक आएगा एनर्जी कंजर्वेशन के पार्ट के ऊपर। तो एक तो एनर्जी कंजर्वेशन, दूसरा है आपका रिफ्लेक्टर टाइप ऑफ पेंट कोटिंग जो छत के ऊपर लगाना है, वो एक है, और रेन वाटर हार्वेस्टिंग करना है तो वो भी। तीनों आप फिनिशिंग स्टेज में भी कर सकते हो अगर कंस्ट्रक्टेड स्ट्रक्चर है। तो सोलर के लिए आज के डेट में बहुत सारा कंपनियां मार्केट में तो अवेलेबल है, इवन इफ गवर्नमेंट की तरफ से बहुत ज्यादा सब्सिडी मिलता है। आई थिंक लगभग 1,38,000 अप टू 3 किलोवाट तक वो सब्सिडी गवर्नमेंट की तरफ से। इवन इफ टाटा आजकल गांव में या फिर कोई भी सिटी में 5,000 रुपया में भी सोलर इंस्टॉलेशन करके दे देता है। तो जो नहीं किए पायलट प्रोजेक्ट, तो एटलीस्ट ये एक यादगार टाइप का रहेगा आपका कि नहीं, हमने कुछ ग्रीन ऐड किया है, एटलीस्ट मेंटर के लिए या फिर मेरा फैमिली के लिए। नेक्स्ट। अभी घर बन गया, घर बनने के बाद आपको अभी देखना पड़ेगा आपने कौन सा अप्लायंसेस यूज कर रहे हो। एसी अगर आपने लिया है 3 स्टार है या 2 स्टार है या 5 स्टार है, अगर लिया है वो भी क्या एफिशिएंट बता रहा है। ग्लास अगर लगा रहे हो तो उसका कोएफिशिएंट क्या है। वेजिटेशन छत के ऊपर रखे हो या फिर बाहर सेटबैक्स के या फिर इंडोर पे, वो सब ये पॉइंट्स आता है इंटीरियर और फिनिशिंग के दौरान। बाकी वेस्ट सिग्रीगेशन कैसे करते हो, एनर्जी सेविंग अप्लायंसेस और वाटर सेविंग जो आप देख रहे हो प्लम्बिंग सिस्टम से आजकल आ रहा है, आपको लगेगा हेवीली पानी फ्लो कर रहा है, लेकिन वो फोम टाइप का होके आएगा, पानी कम पानी आता है नॉर्मली उसमें। तो दोज आर ग्रीन प्रो प्रोडक्ट्स। तो ये ओवरऑल आपको लगेगा कि इनिशियली आई एम स्पेंडिंग मनी, बट इट इज नॉट ए कॉस्ट ऑफ इवन इफ 1%, 0.5% भी नहीं है पूरा इंटर कंस्ट्रक्शन कॉस्ट का, लेकिन पूरा फाइनेंशियली अगर देखेंगे रिटर्न बेनिफिट इसका, आपका जेनरेशन नेक्स्ट जेनरेशन तक इसका इम्पैक्ट रहेगा। ग्रीन बिल्डिंग का इतना बड़ा एडवांटेज है। पुराने स्टाइल का आप कोई भी घर देखो या आप देखो राजस्थान उस साइड में जो राजा महाराजाओं का माहौल देखो, तो उसमें कुछ आपको आइडिया आ जाएगा उस टाइम में नॉर्मली वो क्यों क्यों वो क्या बोलते हैं उसको, बीच वाला जो पोर्शन है उसको खाली रखते थे ना, वो ओपन टू स्काई रखते थे पे पुराना स्टाइल का जितना घर है। क्योंकि हेलो यस सागर जी, सागर जी, एनीथिंग यू वांट टू ऐड? ओके, तो आप देखिए, मैंने प्रायर टू 100 200 इवन 500 ईयर्स एगो जितना सब कंस्ट्रक्शन बन रहा था, उस टाइम से वो लोग ये क्राइटेरिया को पहले इम्पोर्टेंस देते थे, तभी एक पॉजिटिव वाइब्स पूरा घर में रखते हैं। लेकिन ये छोटा छोटा चीजें ना बहुत मायने रखता है। नेक्स्ट, ऑर्डरलेस पेंट, क्योंकि ये एक फैक्टर आज के डेट में बहुत ही इम्पोर्टेंट है। कुछ कुछ को सूट नहीं करता है, एलर्जीज हो जाता है। इवन इफ आपका इसके ऊपर बहुत सारा नेगेटिव इम्पैक्ट आता है, जो भी इनहेबिटेंट्स है उनके ऊपर ही आता है ये एक्टिविटी। तो ये आपको जब भी घर के लिए कलर पलर देखते हैं तो वही ग्रीन प्रो वाला कलर आपको चूज करना है। नेक्स्ट, सोलर वाटर हीटर, जिसमें आपको कम एनर्जी लगेगा। अच्छा, सोलर वाटर हीटर से जाने से पहले एक क्वेश्चन, कितने लोगों के घर में आज की डेट में एसी नहीं है? प्लीज अपना हाथ थोड़ा उठाएंगे, ऑनेस्ट आंसर प्लीज। एसी नहीं है बिल्कुल, जहां पे आप स्टे करते हैं एसी नहीं है। दैट मीन्स सबके घर में है। अच्छा, मुझे आप एक जस्ट छोटा सा एग्जांपल इसमें दे रहा हूँ। आप लोग देखे होंगे, पब्लिक जब स्ट्राइक करते हैं तो रास्ते में टायर वायर वो ला के जलाते हैं। बहुत ज्यादा डेंजरियस है एनवायरनमेंट के लिए, या आपके घर में जो 5 टन का एसी लगा हुआ है बहुत डेंजरियस है? माय सिंपल क्वेश्चन।
Sir, AC is more dangerous.
क्यों? बिना एसी का आज की डेट में हम रह नहीं पाते, बट क्यों डेंजरस है वो? आप थोड़ा सा ग्रीन पॉइंट के ऊपर सोचिए, आपको पूरा आंसर इसमें आ जाएगा।
Actually, previously ACs were generating CFCs, chlorofluorocarbon. So I don't know whether
Yes,
present same gas is being emitted or not. If it is emitting chlorofluorocarbon, then it is very much dangerous because it has a it has carbon footprints.
Very well said, Bhagirathi ji. I appreciate, but I don't want to go into so deeply. मैं एक सिंपल सा आदमी, मुझे इतना इंग्लिश इंग्लिश नहीं आता।
Greenhouse gases, these emits greenhouse gases.
वो आपने बोल दिया इंजीनियर के हिसाब से, आप समझे मैं समझा, आज आम आदमी उसको मैं कैसे समझाऊं? सिंपल लॉजिक
The simple
आप
logic,
हमेशा
I can say, tire you burn once a year, twice a year, but AC generally you run 9 months a year. So by that
दैट
you are
इज
burning more.
दैट इज फाइन। मैं यहाँ
हेलो
पे सोलर
हेलो
हीटर को दिखा के वो क्वेश्चन क्यों पूछ रहा हूँ? यस प्लीज।
सर मे आई स्पीक सर मे आई
यस
स्पीक
वैशाली।
yes sir so in a very simple way general language we can say that it depletes ozone layer
यस
Greenhouse gases means it will deplete ozone layer.
I think in simple language we can understand it therefore it is dangerous if using
बोथ ऑफ यू आर इक्वली करेक्ट, बट माई सिंपल आंसर इज इंडोर एसी का दिखाते हैं। इंडोर एसी में कितना टेम्परेचर आप सेटिंग करते हैं? 22 से 25 डिग्री या 16 डिग्री, 18 डिग्री? हेलो,
Participants are requested to mute your phone. Those who want to interact, they can only unmute. Please mute your phone.
इंडोर एसी कितना टेम्परेचर छोड़ता है? सिंपल क्वेश्चन। आपको कितना डिग्री में रहना है ठंडा में? 18 डिग्री, 22 डिग्री या 25 डिग्री में आप सेट करते हो, लेकिन कभी आप उसका आउटडोर यूनिट के पास जाके खड़े हुए हो? वही सेम एसी का आउटडोर यूनिट ऑलमोस्ट डबल देन द टेम्परेचर वो बाहर छोड़ रहा है एटमॉस्फेयर में।
sir indoor 24 degree centigrade
हाँ, लेकिन आउटडोर के पास कभी जाके खड़े हुए हो क्या वैशाली?
बहुत ज्यादा रहता है सर बाहर
इट इज मोर देन 2.5 टाइम्स हायर।
yes twice more than double
तो मान लो एक एक घर में 2 टन का एक ही भी एसी है, अगर एक कॉलोनी में 100 एसी लग गया तो क्या
हाँ
इम्पैक्ट आएगा एनवायरनमेंट के ऊपर?
so that will be greenhouse effect
यस, मैं सिंपल
greenhouse
एक्चुअली इसीलिए
greenhouse effect
बार बार मैं बोल रहा हूँ कि हमको जितना ज्यादा जरूरी है नेचुरल वेंटिलेशन, नेचुरल लाइट के ऊपर डिपेंड करना है। पुराने जमाने का जो घर बनता था वो बीच वाला आंगन को खाली रखते थे, ओपन टू स्काई कर देते थे, क्योंकि नॉर्मली जो वास्तु के हिसाब से हमारा पोजीशन बोलता है ना, ब्रह्मस्थान बोलते हैं उसको, वही ब्रह्मस्थान है वो सेंट्रल वाला एरिया। वो अगर ओपन टू स्काई हो गया ना, देन एंटर पॉजिटिव एनर्जी आएगा, पॉजिटिव ही पॉजिटिव सारे घर में आपके। मान लो मैं एक छोटा सा एग्जाम्पल इसमें और दे रहा हूँ। आपके पेट के ऊपर अगर कोई आदमी खड़ा रहेगा, आप कितना देर तक उसको झेल सकते हो? 1 मिनट, 2 मिनट, कुछ देर के बाद आपका सांस फूलने लगेगा, क्योंकि वो सेंट्रल पोर्शन है जहां पे हम ज्यादा नेगेटिव चीज को नहीं रख सकते। तो ऑल आर ग्रीन बिल्डिंग, ये सब चीजें ना सब जुड़ा हुआ है, कोरिलेटेड है। नेक्स्ट प्लीज। वैसे और कुछ ऐड करना चाहते हो क्या? आपने हाथ उठाया है।
सर वो रेज किया था आपने पूछा था ना कि कौन एसी नहीं यूज करता है सो वी डोंट यूज एसी उसके लिए रेज किया था
ग्रेट टू हियर एक्चुअली।
वी डोंट हैव एसी सिर्फ कार में रहता है एसी वो भी जब हॉट रहता है तभी ऑन करते हैं
तो आप
अदरवाइज कोई
नॉर्मली नेचुरल लाइट, नेचुरल वेंटिलेशन के ऊपर डिपेंड
यस
करते हैं ना?
यस यस
That-
ऑफिस में भी कभी एसी नहीं लगाया और घर में भी अभी तक नहीं लगाया और लगाएंगे भी नहीं
That's good. That's good. You are from Maharashtra?
Yes, Maharashtra, Satara district, Government Engineering College.
Okay,
We have
okay.
fair weather, इतना ज़्यादा नहीं रहता है. We don't have extreme climate, इसलिए वैसे इतना ज़रूरत भी नहीं पड़ता है. And if greenery is too much. It is in western Maharashtra, so greenery बहुत है, तो इतना ज़्यादा वैसे ज़रूरत नहीं पड़ता है.
Okay.
Yes.
तो अभी गवर्नमेंट जो सब्सिडी दे रही है सोलर के ऊपर, हो सकता है आने वाले दिनों में इसको ना दे, तो आज प्रोजेक्ट के तौर पे आप ले लीजिए अभी इसको, लेके आपका कमिंग जनरेशन जो है उनके लिए एटलीस्ट एनर्जी बचा के रखिए.
यस यस. अभी सर जो हॉस्टल वो सब है उसके लिए वो सब्सिडी मीन्स अच्छा रहता है, एफिशिएंट है, बट इंडिविजुअल ड्वेलिंग यूनिट के लिए इतना वो इकोनॉमिकल अभी नहीं प्रूव हो रहा है. बट
नहीं, दो सिस्टम है इसमें, एक तो है ऑन ग्रिड, एक है ऑफ ग्रिड. आप ऑन ग्रिड ले लो, ऑन ग्रिड लेने में आपको जो बिल्स आएगा उसमें रिडक्शन हो जाएगा.
यस. अभी ट्राई मीन्स हमारा वो इंडिविजुअल यूनिट के लिए भी अभी सब्सिडी के लिए सोच रहे हैं, बट यहाँ पे गवर्नमेंट कॉलेज में तो ले लिया है. मास होता है ना, सोलर पैनल ज्यादा है तो हो जाता है.
हाँ, नहीं ये पीएम
डेफिनेटली
स्कीम का, पीएम सूर्य घर योजना चल रहा है ना अभी पूरा भारतवर्ष में.
यस है ना,
तो
है,
ये
शुरू है ना,
हम्म,
वहीं से
तो इस
एमएससीबी से ही है.
तो ये आप लोग आज पायलट प्रोजेक्ट अपना बिल्डिंग को लीजिए या इंस्टीट्यूट को लेके इसको करवाइए.
हाँ सर, एज अ प्रोजेक्ट फाइनल ईयर स्टूडेंट्स को अभी इस साल दे रहे हैं सर. ग्रीन एनर्जी के ऑल ऑप्शंस वी आर ट्राइंग सर. रेन वाटर हार्वेस्टिंग भी किया है, भी उसका एनवायरमेंटल
नहीं,
एयर फ्रेशनर वो भी लगाया है.
वैसे वैसे पेन एंड पेपर में प्रोजेक्ट हुआ या रियल में हुआ है
नहीं
प्रोजेक्ट?
नहीं, रियल में रेन वाटर हार्वेस्टिंग किया है.
देन इट्स ग्रेट. देन इट्स ग्रेट.
Recycle water used for this gardening and all, and
यस.
therefore there is lot of saving in water. Water bills are reduced like that, and even forest, that green area is also increased in campus. अभी वो कावा क्या बोलते हैं उसको, जापानीज टेक्निक है ना, क्या नाम नहीं रिकॉल हो रहा है, मियावाकी. मियावाकी
यस.
एक जापानीज टेक्निक है, उसमें डेंस फॉरेस्ट क्रिएट करते हैं. ऐसे ही बहुत डेंस फॉरेस्ट.
वो कम पानी में वो.
हाँ,
यस यस.
नेचुरली दे आर ग्रोइंग. और ऐसे 2-3 प्रोजेक्ट हम लोगों ने यहाँ पे विजिट किया है, और हमने कैंपस में भी ऐसा किया हुआ है, थोड़ा डेंस किया है. बट मियावाकी का प्रॉपर एक टारगेटेड एरिया लेके उसमें फॉरेस्ट ग्रो किया है. यहाँ पे 2 जगह तो है हमारे सातारा डिस्ट्रिक्ट में.
तो जैसे आपने किया है, आई विल एक्सपेक्ट एटलीस्ट ऑल फैकल्टी मेंबर, तो इसमें अगर 20% या 10% भी पायलट प्रोजेक्ट के तौर पे ग्रीन बिल्डिंग के ऊपर काम करे ना, ये मेरे लिए सबसे बड़ी खुशी की बात होगी. एंड आई विल ऑल्सो मैं यहाँ अप्रिसिएशन एंड रियली आई विल बी थैंकफुल टू पंकज सर अगर ये प्रोजेक्ट को वो आगे लेके जाए.
सर मियावाकी एक तो एक म्यूनिसिपल कॉरपोरेशन ने अंडरटेकिंग किया था, रहमतपुर. और एक वो जो डॉक्टर है एक ऐसी, वो सोशल सर्विस वगैरह करते हैं, तो उन्होंने अपने फील्ड में मियावाकी ग्रो किया हुआ है फॉरेस्ट. ऐसे दो हम I have observed.
Sir, with your kind permission, I want to say something.
Please, sir. It is your platform. You can always.
No, sir. Actually, we have another session exactly at 3:30. So definitely our next expert
I am
will
already
join.
concluded my part. I have already concluded my part, but last 5 minutes, I think we have.
Thank you, sir, for your guidance.
If anybody wants to anything add, then you can use the chat box, or you can directly reach to me on syama.misra@adityabilla.com. I can also write it in the chat box also.
Sir, is it concluded?
I am through.
Is it concluded, sir, the session?
I am through. I am through.
Okay. Okay. So, I want to thank Engineer Shyam Sundar Mishra, sir, for delivering a nice talk on advancement and forthcoming innovations in sustainable construction. Our participants have definitely gained some new techniques, new technology, and new knowledge from you, sir. So, with your kind permission, we want to close this session. I am again thankful to you for your presence at this particular health condition.
So nice of you, sir. Thank you so much. It was a little bit.
Okay, sir. With your kind permission, can we stop this session, sir?
Yes, 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 please. Thank you. Thank you.
Okay, thank you, sir. Thank you, all the participants. Please stay
Request,
online. Stay online
request,
because our second session will start at 3:30. So, thank you again, sir.
request everyone to share your feedback on the mail given. Thank you, Pankaj sir. Thank you, Mausumi, for supporting. Thank you all, my dear friends and faculties. Special thanks to Baisali. May I leave
Mosumi.
now?
Okay, Mosumi.
You are, sir, you are more, you have given us more knowledge. We are just learning. Thank you. That's it.
Again.
हाँ
सर जॉइन कर सलेंడి.
Okay, thank you. Mosumi. Sir, namaskar.
नमस्कार.
Sir, namaskar. uh, again, this is the second session of our 6-day Atal Online Faculty Development Program sponsored by AICT. At the outset, I welcome our chief speaker, Professor Dr. Sisir Kumar Sahu, sir. Sir, good afternoon, sir, and namaskar.
Good afternoon. Namaskar.
I welcome all the participants to this second session, and today's topic is fiber fly ash utilization in structural applications for sustainable construction. So this is my responsibility to introduce our speaker. Already our speaker sir has taken one has already delivered one talk, but again I want to introduce sir.
Briefly.
Professor Dr. Sisir Kumar Sahu is currently working as Professor HAG in Department of Civil Engineering, National Institute of Technology, Rourkela. In addition to this, he has additional responsibility of Chairman, Press and Public Relations and Local Coordinator GIN of the Institute. He has served as Head of the Department of Civil Engineering, Dean, Planning and Development, and Chairman, Board of Trustee of the Institute, and Chairman, Library of the Institute. He received his PhD in Aerospace Engineering from IIT Kharagpur on the area of dynamics of composite plates and cells, and did his postdoctoral research at ISVR, Southampton University through Indo-British UKIERI Fellowship. He has supervised 12 PhD besides numerous MTech and BTech projects in structural dynamics and waste management. He is the author of more than 110 publications with nearly 77 peer-reviewed international journals with SCI Scopus indexing with 1500 citations and an H index of 23 dealing with mechanics. He has written 4 book chapters. He has been granted a patent on fly ash angular aggregates. He has handled research projects on structural dynamics of composites and innovative fly ash utilization for structural applications. He has developed a structural dynamics laboratory with state-of-the-art FFT analyzer, UTM-COM fatigue testing machine, Instron 8862, along with composite fabrication test setup with nano fillers. He has delivered keynote address in many conferences in Germany, United Kingdom, Singapore, Hong Kong, Indonesia, etc. His teaching interests include structural analysis, finite element method, plates and cells, and composite structures. His main research interests include structural mechanics, finite element modeling, dynamics, stability, fracture mechanics, plates and cell structures, including nanocomposites and waste management. So, sir, I welcome you to this session on the topic fiber fly ash utilization in structural applications for sustainable construction. So I sincerely request you, sir, to start the session.
Thank you for your nice introduction. So let me share the screen. What's wrong? I think I have to do this first. Is this slide visible?
Yes, sir.
Okay. So like you told, the first project actually composite dynamics project was funded by a DST project. This project was funded by Government of Orissa. One day work secretary calls us to take care of 2 things. So give us some innovative use of fly ash, and he has given us fly ash pellets to test it. Fly ash pellets manufactured by Impha Chaudhar to test whether it can be used as construction and put into specification or not. Then we looked for what can be innovative. He told that conventional use of fly ash utilization, we know that. We wanted to know something newer use of fly ash utilization, so that actually it will be used in more quantity. So innovative fly ash utilization for sustainable development. Fly ash is a byproduct in thermal power plants and is a serious environmental issues. In India, annual generation of fly ash have jumped to 200 million tons per annum during the last decade. In India alone, fly ash landfill covers an area of 50,000 square meter. So in Odisha, the production is 30 million tons per annum. The Ministry of Power, Government of India estimates 600 million of tons, 600 metric ton of fly ash generated in 2031-32. So the World Bank also cautioned India that disposal of fly ash would require 1,000 square kilometer of land per person in few years. So issue of proper disposal is very critical, and new technologies are to be explored for fly ash utilization to save the valuable land. You can see some of the Hindalco fly ash. You can see the level of the fly ash deposited and taking away the landfill, and it is spilling also to the farms. This is a NTPC Odisha ash pond developed a crack and flowing to the land, which makes the land very much in a bad shape, incapable of cultivation also. So this is air pollution from ash ponds from Chhattisgarh. This is ash pond flowing to river in West Bengal. So this is the size of the problem we need to address to. So this is the fly ash scenario in India, production versus utilization. So you can 2020 it is 240, 2025 it is 300 million tons, 300 million tons. So and there is a large gap, though the utilization is increasing every year, but the production also increasing. So more than that, so and there is a large gap between the production and the utilization. So that is why it's government concern to have more utilization. These are some of the fly ash uses. The conventional fly ash uses is manufacture of Portland Pozzolana cement, which we tell PPC, that has been done plenty by the cement manufacturer. When some years ago, when fly ash was lying near the thermal power plants, it was taking huge land, but cement factories has come, research has been done, and cement factories come forward to use fly ash in the clinker itself, so that Portland Pozzolana cement can be manufactured. Besides this, government is also encouraging use of fly ash bricks, so that this is one of the part of the green building projects. And government of Orissa also has taken us to a plant which manufacture autoclave aerated concrete, AAC, use of one of the uses of fly ash, and given us material throughout the state, including IMFA pellets and fly ash throughout the state. They have supplied the material, and it is also being used up as embankment, structural fill, and mine reclamation. So mine filling, wherever we get coal or iron or anything, it has to be reclaimed by sand, or it can be done through fly ash. So road subbase, how the road subbase will be used, and soil stabilization. And some years back, I have worked in a problem called fly ash lime gypsum, FALGY. Fly ash lime gypsum. So these three, FALGY was acting as a substitute of cement, though not of same compressive strength, but it still can be used as a masonry mortar. I have done this FALGY on 1990s, that time 1992, that time I have done some work. Then recently, like government pushed forwards for new innovative ways of construction, innovative ways of use of fly ash. So we thought of lightweight aggregate. So in fact, lightweight aggregate, as I have told you, IMPA fly ash pellets has been given to us. That is one of the lightweight aggregate. And we make some study. We find actually one patent and one or two papers on IMPA pellets. These are called pellet spins. That's actually circular shaped. So then it comes to our minds, can it be angular? Can it be angular shape? So then we got one Australian patent and one paper from the same author. So then we thought of manufacturing this lightweight aggregate. So lightweight angular aggregate. Lightweight aggregate is being manufactured. Circular aggregate is being manufactured by IMPA and a lot of people in the country. And this lightweight angular aggregate is our patent, which we have applied and got within 1 year. So replacement of, besides this, we have tried replacement of cement, sand in RCC construction. We have tried to use it in tiles, paver blocks, and wall panels. These are red colors are our area in which we have done. But besides this, fly ash can be used as fields, waste stabilization, solidification, asphalting, concrete mineral filler, numerous agricultural applications as well. We have tried these three: lightweight aggregate, replacement of cement, sand, tiles, paper blocks, and wall panels. Cement applications, as I have shown you, this is graphically has been shown. ASC blocks, fly ash bricks, binder mortar, cementitious material in PPC cement, and future applications: sand, lightweight aggregate, ceramic tiles, and element extraction. Element extraction means some of the precious elements are there in the fly ash. So the extraction can be done also. Some people have already tried. Some papers I have gone through. Some people have tried, but we have done the other way. We have done the lightweight aggregate, tiles and paper blocks, and sand replacement, cement replacement. So it has tremendous environmental impacts and is sustainable. It reduces greenhouse gas emission as a cement replacement material. For every ton, 1 ton of cement produces about 6.5 million British thermal units of energy consumed. Replacing that 1 ton of cement with fly ash would save enough electricity to power the average American household almost a month. For every ton of cement produced, about 1 ton of carbon dioxide is released. So this reduces volume of costly landfill space used for disposal of fly ash. Land is so costly nowadays. So that is also one of the main concern. One is landfill. Second one is, you might have seen a lot of the, for sand also, a lot of mines have finished, a lot of river sand have been finished in many locations. So we need to be cautious for this use. And what is the chemical composition? Because fly ash is a byproduct, material chemical constituents can vary considerably, but all fly ash includes silicon dioxide, something like 25 to 60%, calcium oxide, 4 to 12%, iron oxide, 5 to 25%, aluminum oxide, 10 to 30%. Depending upon source coal, may include one or more chemicals in trace amounts: arsenic, beryllium, boron, cadmium, chromium, lead, manganese, mercury, molybdenum, selenium, strontium, thallium, vanadium. So these are materials in trace amount, small amounts available in fly ash also. So some of them can be used for, some of them are very much harmful, and some of them can be used also for specific purposes. So efforts are required to find every ways of this waste product and saving land and natural resources for the future generations. Thus, a study of fly ash utilization in structural applications is of current research interest with practical significance of sustainable development. Studies are available for utilization of fly ash, bricks, manufacture of Portland cement, and considering cement replacement in concrete roads. So these are available, but we thought of going beyond this. The techniques of fly ash utilization. When fly ash is added to concrete, it possesses dual role for the strength development. Fly ash reacts with the released lime during hydration and produces binder, which render additional strength to the concrete mass. So fly ash gives additional strength. Fly ash also gives the unreactive portion, also gives used as a fills of the matrix to give packing effect, results in increased strength. Both way it is helpful. Studies are tried for sand and cement replacement of concrete with fly ash. Plain cement concrete, reinforced cement concrete. Then we have tried tiles, ICBP, integrated concrete block pavement, lightweight round fillets and angular aggregates, wall and floor panels. So these last four is of our new contribution, but we have also worked in PCC and RCC also. These are the, you can see around many buildings, there are floor tiles. So we thought of, these are all normal tiles. We thought of concrete tiles. Let us use some portion of fly ash in these concrete tiles. Concrete tiles are also used as road construction also. Somewhere it is used also for road construction. So that also we have tried. Particular grade of concrete we have tried, which is used for, it is used in National Highway in Jaipur. So and these are some of the other places where it is also used driveway. So the objective is decided based on to explore the possibility of using fly ash in concrete as partial replacement of coarse and fine aggregate for plain cement concrete for RCC structures as in beams. To study the determination of optimum percentage of fly ash with cement with replacement of sand and cement for use in interlocking concrete block pavement for precast road construction. Precast road construction has a significant advantage wherever it is inaccessible and wherever drainage issues are there, we cannot have conventional bituminous roads. So precast roads are better in that way. The applicability of supplied fly ash based round pellets, lightweight aggregates replacing coarse aggregate substitute in PCC and RCC is also examined. The applicability of fly ash for development of a new lightweight angular aggregates in structural concrete vis-a-vis RCC with conventional hard granite aggregates is examined. This is our patent. Last one. Scope of this study. The scope includes effects of different parameters as percentage of fly ash and compressive strength, tensile strength, modulus of rupture, water absorption, dynamic characteristics, including determination of natural frequency for fly ash based green tiles. We call it green tiles. The study includes the effects of different percentage of fly ash and compressive strength, flexural strength, abrasive strength, and water absorption of green ICBP for laying overs upgrade. It deals with the suitability of local available fly ash, round aggregates or pellets. Round aggregates are called pellets, and its behavior, replacement of coarse aggregate on the flexural and splitting tensile strength in PCC, and shear behavior, flexure and shear behavior along with crack pattern of RCC beams. So we have tested some cubes, test some cylinders, test some beams as well, because government wanted to, before government wanted to permit use of pellets, government wanted to, some agencies to test it and see its suitability. This deals with development of lightweight angular aggregates from fly ash and its behavior on full and partial replacement of coarse aggregates on the compressive strength, splitting tensile strength in PCC and flexural behavior along with crack pattern of RCC beams. The applicability of these low density aggregates, because these are low density, lightweight. So in structural concrete, besides conventional hard granite aggregate is to be examined. Besides strength, this gives, this weight is less. That is why the self weight of the structures becomes less. That way it is more advantageous. Collection of fly ash, the experimental program, collection of fly ash. In fact, the government of Orissa ordered all executive engineers of the state who are nearer to the thermal power plants to supply us their fly ash. So we don't have to bother. They have supplied throughout the state. We have done the characterization of fly ash first, what it contains, what is the sieving, etc. We do it. Then preparation of specimens. We have done cubes, tiles, paper blocks, lightweight circular angular aggregates with fly ash. Then testing. So collection, characterization, preparation of specimens, and testing. All these samples. Testing of tiles, paper blocks, pellets, angular aggregates, and RCC beam for flexure and shear. In fact, first actually we have tried Portland slag cement. Then actually we saw actually when we showing 1 year actually we spent on this, nearly 1 year. So we saw that the results are some kind of a less reproducible, and probably because of it is already contained slag. So then we switch over to OPC, Ambuja cement. So we have done both slag cement and OPC, local available sand with fine aggregate with specific gravity 2.68, locally available crossed granite stone chips as coarse aggregate, maximum nominal size is 20 mm. The grading of 10 mm coarse aggregates were also used. Tiles, in the case of tiles, we have used 10 mm size aggregate. Rest normal concrete, we have used 20 mm size aggregate. High yield strength deformed bars, FE 500, conforming to IS 1786, and the diameter of the bars are 10 mm and 8 mm. Local tap water, lightweight fly ash aggregates or pellets are of 8 to 12 millimeter size and specific gravity 1.8. Fly ash from multiple sources from different parts of the power plants of Orissa. The main plants are Ganesh Metallic near Raulkela, Bhushan, Sambalpur, Nalco Anugur, NTPC Talcher, RSP Raulkela, JSPL Kalinganagar, and JSPL Anugur. These are the places mostly we have used majority of tests, though we have got all. Typical graph obtained from XRD test of fly ash from Bhushan Sambalpur. Bhushan Sambalpur we have used a lot. So this shows actually silica and quartz is dominating in the fly ash, the composition. There is less quantity in calcium quantity is less. Sand replacement. To study the sand replacement with fly ash, mixed design was prepared using M20 concrete as per the mixed design code 10262. sand was replaced partially with fly ash up to 60% weight till reverse trends. The parametric effect of sand replacement in fly ash concrete we have tested through compressive strength, 150 millimeter cubes, flexural strength, 100 into 100 into 5 millimeter prisms, split tensile strength, 100 millimeter diameter and 200 millimeter length cylinders at 7 to 28 days are tested, are casted and tested. The optimum percentage of replacement of fly ash is noted. This is the compression test machine. This is the flexural strength test. This is the split tensile strength. You can see how the cylinder has been kept for split tensile strength. This is the, we have got some molds of different ICBP paper blocks. One is zigzag, I section, dumbbell, rectangular tiles. These are the various shapes we have done it, and the corresponding tests as per the code: compressive strength, flexural strength, water absorption, and abrasion resistance. These are the tests we have done it. This is the paper block molding machine. We have procured one from the project fund. We have also procured an abrasion resistance setup for this project purpose. Then beam testing. Full-scale beams are also tested. One control beam with conventional materials and beam with optimum sand replacement in line with 100% pellets also used, replacing 10 millimeter down aggregates. The pellet supplied was of 8 millimeter and 12 millimeter size of coarse aggregate in control concrete mixture of 20 mm and 10 mm down. For comparison purpose, 10 mm down aggregates replaced with fly ash based pellets. The beam designed as a rectangular under reinforced section for flexural failure as per IS 456 2000. This is the dimensions of the beam. The beam is of 200 millimeter width and 250 millimeter depth. There are the main flexural reinforcement is 3 numbers of 10 millimeter dia, and the top we are given 2 numbers of 8 millimeter dia, and stirrups were also given. This spar is 1.8 meter, width of the beam is 200, depth is 250, effective depth is 225, L by D ratio tested beam is this. So the maximum L by D ratio, the concrete grade is M20, grade of steel is Fe 500. So this is the experimental setup of the beam. On the this is tested under a 50-ton load frame. Dial gauges, 3 dial gauges are placed at the center and at L by 3 and L by 3 position. Materials for concrete tiles, Portland slag cement. We have also done the same test with OPC as well. First we have done slag cement, then we have done OPC, fine aggregate. Mixed proportion was 1:4. Casting of the tiles has been made using suitable rubber mold and by vibration table. And the local available chips were 10 millimeter chips were used. So this is tiles. We have done water absorption test. Sorry. As per the tiles code, we have done water absorption test, weight transverse strength test, abrasion resistance test, freeze thaw for durability test, freeze thaw test for durability, modulus of rupture testing machine. We have done tested the find out the tensile strength by modulus of rupture testing machine, impact testing machine, and natural frequency of the tiles also. This is natural frequency. This is impact testing machine. This is the modulus of rupture machine. Then freeze thaw test for durability. The tile specimens is measured to its constant dry and wet and then immersed in 3% sodium chloride solution. Then it is kept in a freezing chamber at minus 15 degree, and then 16 hours is kept in a thawing chamber for 8 hours. So freezing, thawing, 25 cycles, I think we have done it. This constitute one cycle. Again, it is kept in freezing chamber for 8 hours and thawing chamber, after which it is taken thawing chamber. So 50 cycles are completed. After 50 cycles, specimens are tested. Tile is considered to have passed the freezing and thawing test. At the completion of 50 cycles, all specimen remains unbroken and no individual specimen loses more than 1% of the original dry wet. So that is the course criteria, and that's satisfying the freezing. This is the freezing chamber. This is the thawing chamber. Tiles of different shapes and different fly ash composition are casted. Small check, big check, 9 square, all 20 numbers. We have 0% replacement to 10% replacement by fly ash, 10% sand replacement, 10% cement replacement. Tiles casted in laboratory. This is the big check tile. This is the 9 square tile. All casting has been done in the laboratory. Wearing course application. Left for vibration after wearing application. Backing course applied over wearing course. Properly vibrated and kept for dry. The mixed design was done for concrete grade M40 by considering medium traffic rigid pavement, because we thought of ICBP to be used as pavement, or else you can go to from 120, M20, M30, whatever we are seeing around is not M40. M40 we have tried as a paving material. M40, these are all M20 or M30 material, whatever you are seeing around, but we have tried M40 to make it as a medium traffic rigid pavement material. The shapes of the paver block considered in this are zigzag 60 millimeter, zigzag 80 millimeter, rectangle, I-shape, pentagon, sand and cement replacement, fly ash up to 40%. The corresponding flexural and water absorption were determined. Durability, freeze thaw test, characteristics of ICBP has been studied, compared with conventional control concrete in blocks using freezing and thawing chamber respectively. These are the paver blocks. Different shapes. Then compressive strength of paver blocks. This is the freezing chamber. This is the thawing chamber. Then result and discussion. The mixed design of M20 concrete was done. Everybody can try it in their lab if he is a teacher or working anywhere. So the mixed design for M20 concrete was done as per the IS 10262. The sand was replaced by weights like 0%, 10%, 20%, 30%, 40%, 50%, 60% with fly ash. Sand is replacement. This is for sand replacement. Different percentage of fly ash. This is the mixed proportion. This is a slag cement of this proportion we have used. 1:1.7 to 3.18. The water cement ratio is decided based on the recommendation of mixed design code. By adding fly ash, the requirement of water increased due to increase in fines, and water cement ratio has to be increased to get a workable mix. So when you add fly ash, it becomes a harsh mix. So water is added extra to get a workable mix. Even more amount of super plasticizer has been also used in case of M40 mix. Compressive strength of tubes for sand replacement. As you can see, the compressive strength initially increased with 10%, but gradually decreases, and sometimes you can see SR20 decreases, but SR30 increases. So that kind of a thing is seen in slag cement, but OPC shows clear trends. This is the sand replacement versus compressive strength. The 28-day strength up to 60% of replacement. Then flexural strength. Flexural strength requirement is minimum 4.5 or 5 was there. So it is satisfying that way, 28-day strength. So, and you can see that here in this case for 7 days, it goes on increasing up to SR 30%, but then decreases. %30 is the optimum in this case. Then we results on the split tensile strength. Similar manner, 30% seems to be the optimum percentage. Same thing, we can get it from graph as well. Sand replacement versus at least 30% sand can be replaced conveniently. It depends whether your structure is subjected to compressive forces or tensile forces. Accordingly, you can corresponding strength you can consider and find out the optimum percentage. Compressive strength of tubes with pellets with the replacement of 10 millimeter aggregates for M20 concrete. You can see 31, then 26, then 34, like this 35, 32. So little abrupt trend when you do with slag cement. Variation of compressive strength with coarse aggregate, replacement by pellets, but it is showing standard strength comparable to the normal aggregate. That way, we recommended for it can be used. Cracked beam during failure. This is the normal control beam. This is for the control beam, 10, 20, 30% control beam. This is beam with 30% replacement of fly ash, replacement of sand by fly ash, beam with 100% replacement of 10 millimeter aggregates to fly ash. You can see with fly pellets, the deflection is decreasing. Its deflection is decreasing, means it is showing its stiffness. Same thing with fly ash also. This is the low deflection curve. Whatever we have seen before slides, same thing in the graph form. Then this is the ICBP. Green ICBP, we name it. This is the recommended grades of paver blocks for various traffics. As you can see, we have taken a city streets, small and medium market roads, for low volume roads, utility costs. For this, we have taken M40. If it is to be bus terminals, it need to be tested for M50. For medium market roads, we have considered this one and take M40 into consideration. So, and the recommended paver block thickness size is 80 mm. Whatever you are seeing on the road, most of them are 50 or 60, M30 or 35. It is used for building premises, monumental premises, landscapes, public gardens, domestic drives. So usually it cannot be used as a pavement, but just you can move around, or 60 can be used for car parkings. And the mixed design considered is 1:2.25 is to 2.25. Water cement ratio 0.4. So this is the ICBP replacement, 10%, 20%, 30%, 40%. So these are the corresponding strengths, compressive strengths. As you can see, with increase of fly ash 10%, the value increases. Then it decreases. Here it is. It looks like this. All of the paver blocks are in the same manner. So at least 10% we can conveniently replace, or more we can replace, keeping the same strength. 10% it is showing optimum, means more strength, but it is showing similar kind of strength, this one to this one also. These three, so 20, 30, up to 30% also we can go getting similar same strength. Then fresh concrete mixes with OPC for cement replacement with fly ash in paver block. Grade M40, this is the cement quantity. Then this is the 10%, 20%, 30%, 40%. This is the material. Different, this is fly ash. Different percentage that goes on increasing. Water cement ratio is kept fixed, 0.4. Sand, coarse aggregate. And this is admixture. Sand replacement. This is for cement replacement. This is for sand replacement. Cement is fixed. Sand is changed. Sand is changed. Both we have tried. Then compressive strength. Compressive strength, you can see increasing, maximum increasing at 10%, but it is still more than, this is 54, this is 57. Still we can use this 20%. This is 53, this is 30%, 54. So we can still use this up to this. If it is a I section, if it is zigzag, this shows the highest, 20% is the highest. If it is a I section, 30% is the highest. So based on that, we can accordingly use this corresponding safe. This is the 20 days strength, 54, 66, 64, 58, 30%. Every 30% satisfy the 0% strength. So easily 30% we can replace sand replacement with OPC. This is with OPC. Very good trend it shows. This is 7 days, this is 28 days. Zigzag showing the highest strength. Results of the cement replacement with the fly ash in paver blocks. 7 days, 28 days. We can see the graph here. This is 7 days. This is the 28 days. As you can see, the strength increases. The strength increases with addition of fly ash. And you can see this is without fly ash. We can get more or less 30% without fly ash. So with 30% replacement, easily we can get the same strength as without fly ash. Yes. This is flexural strength. This is sand replacement with fly ash. This is the 7 days flexural strength. Similar to 30% showing optimum. But here it's not showing 30% optimum. Here it is showing 20% optimum. When I talk about cement replacement with fly ash for flexural strength, for compressive strength 30%, for flexural strength 20%. But I think every value is above 4.5, which satisfy to be used in road concrete. Flexural strength of concrete roads has to be minimum 4.5 as per the course. Even 40% also satisfied. Freeze thaw test for durability. Initial weight, final weight, and you can see the percentage, and it is less than 1%. 28 days of ICBP with cement replacement with fly ash. So here you can see with addition of fly ash, this increases, then started decreasing, but more than the original one. So that way, so based on this, based on the corresponding shape has to be used after proper testing. Cement replacement with fly ash for different shape of ICBP. This is flexural strength. All values are above 4.5. Which makes them suitable for use as a pavement material. Then water absorption. Water absorption is, I think the satisfying level is 4%, and everything is below 4% except this one. Abrasion resistance. Actually, abrasion testing I will show you. Abrasion, I have shown you the equipment. Even the video is there. How to cast it, how to test it. Abrasion resistance. The abrasive value is nearly 0.7, and abrasion is decreasing with 10%, then increasing with increase of fly ash for different shapes. Next is the green tiles. Green tile. So the tile first testing is called 28 days weight transfer strength. This is given as per the code, tile code. So we have done sand replacement, percentage of sand replacement, and this is the, so it increases, and finally at 30% it decreases, but more than 0% value. Here it goes up to 20%, 30% it is less. Cement replacement, you can go up to 20%. Percentage of fly ash replacement versus weight transfer strength of tiles. So this is water absorption, 20%, 30%. I think it is 4% or 6%, the maximum water absorption. So if it is 4%, we can limit ourselves to 10%, but it has to be checked. I forgot whether there is 6%. If it is 6%, then we can go up to 30%. 28 days water absorption of tiles with cement replacement. Percentage of fly ash replacement or cement replacement. So it goes on increasing and highest with 20% and 5.23 at 30%, which is much more than 0% replacement. So it can easily be used. Percentage of fly ash replacement versus water absorption of tiles. So water absorption increasing with the increase of percentage of fly ash, and wherever code restrict, I think 6%. 6%, it is all both are less than 6%. Results of cement replacement with fly ash for concrete tiles. There might be figure as well. Yes. This is sand replacement, flexural strength. So the sand replacement with fly ash versus flexural strength of concrete tiles. So you can see 20%, 30%, but everywhere it is more than 4.5. So it can easily be used for road construction. Water absorption. Water absorption, one thing goes. Water absorption, 30% also 2.36% is. And then we have tested in vibration test of natural frequencies of different cement replacement, 0%, 10%, 20%. So what we do actually, you know that I use work in dynamics. So we have the FFT analyzer. So we have tested it. We saw that this is an indication of the stiffness. This it gives an indication of the stiffness. So as you add fly ash, the stiffness goes on decreasing. But second frequency here is increasing, but less than the normal. Natural frequencies with cement replacement, that is with, this is with water absorption, this is with sand, this is with cement replacement. This is with cement replacement. So it's showing a trend of decreasing with increase of percentage of fly ash. Then actually our fly ash based lightweight aggregates. Fly ash based lightweight aggregates. These are lightweight pellets supplied by government from IMPA Chodar. These are round shape, 8 to 12 mm. We have done the compressive strength of tubes with this percentage of aggregate replacement. So this is how the compressive strength with percentage of aggregate replacement. You can see mostly increasing. So this value is 19.4. Every value is higher than that. And 28 days value, except the initial 10%, all values are close to 35, 10, 20, 30% is close to that. Beyond then reduces. This is split tensile strength. Split tensile strength also optimum is 30%, but this is 1.874, 1.874. This is 2.359, which is higher than this. 7 days. Similarly, this is 2.845, and this is also 40%, also more than that, 3.2. This is flexural strength of prisms. The strength increases with increase of aggregate replacement. and optimum showing 30%. But still more percentage can be used up to 40%, which is higher than the without pellets. Cubes replacement by fly ash angular aggregates. Fly ash angular aggregates, as you can see, have I told you how to manufacture fly ash angular aggregates? Actually, we have done like this. Fly ash angular aggregates, we have manufactured two ways. One, we have added fly ash with a admixture, which is like gum-like. Then put it to furnace. Something like 1250 degree gives us the aggregate. So we have also used another method for manufacturing the two ways, and this is the compressive strength. This is the cylinder strength. So what is happening? Compressive strength 28 days increasing, decrease, but more than this. So something like 20% is optimum. Split tensile strength 10% is optimum. Prism 20% is 3.36 is the 10% is optimum, but 20% value is also higher than the 0%. Then testing of RCC beam for flexure. So here we have seen hairline cracks on flexural beam. This is a 100% aggregate replacement with fly ash pellets. This is a normal aggregate. This is normal. This one is normal aggregate. This bottom one is with fly ash pellets. What we saw the difference? Initial hairline cracks appeared, but the failure loads are also different, but comparable. Load deflection curve. Manufacturer of fly ash based lightweight aggregates. Oh, this here is manufacturer is coming. Different water to fly ash ratios and different sintering temperatures we have tried. We have tried actually many ratios. We have tried many ratios and many temperatures to get the aggregate, which gives good aggregate. Everything give aggregate, but depend upon what is the quality of aggregate. So these are the trials. The first one is fly ash plus water, temperature 1150 we have tried. To fly ash plus bentonite. This one with a admixture, fly ash with water. Then these are all with bentonite, fly ash with a super plasticizer with bentonite fly ash ratio 1300, 1250 gives actually our optimum. Fly ash, Bhushan steel plant plus water plus super plasticizer. Water to fly ash ratio 0.4 and 1250 degree centigrade reached within 7 hours, and at 1250 it remain at 3 hours. This is the temperature. This is the temperature. So this way we have manufactured this one and bentonite. So both the process with sintering temperature at 1250 within 7 hours, and at the 1250 3 hours gives us the best aggregate. You can see it here. Different trials we have done it. This was the aggregate, best aggregate. Disc pelletizer. We have put it into a pelleting machine for mixing. Pellets are used for, this is for round pellets. This is used for round pellets. Of course, we have not manufactured IMPA, but during our angular aggregate also we have used this pelletizer. This is a briquetting machine. So in fact, after it is being sintered, we put it in, we manufactured in a briquetting machine, then we put it to center. So first the mixing is done with the disc pelletizer or mixing machine. Then we have done the briquetting. Then we have put it into a sintering 1250. This one the fly ash aggregate update. This one is the briquette. This one the aggregate. You can see little porous, looks to be little porous, which makes it lighter. Bhushan steel plant, water cement ratio 0.2. Sintering, either bentonite is, so once we have used bentonite, once you have used super plasticizer. Fly ash based lightweight angular aggregates. These are multiple trials we have done it, and finally this aggregate bottom one also with admixture we have got it. And yes, this one 1250, 7 hours briquetting. And this shows the aggregate shows this property, crossing strength. So 2-3 types we have done it through 2-3 processes. Aggregate 1, aggregate 2, aggregate 3. So everything was satisfying, but actually which one is better that way? Crossing strength should be less than 45. Everything is satisfying, but less is the better. So this is the aggregate 1. This is impact value. This is specific gravity. So specific gravity wise, this is better because it is lightweight and showing similar 23, 27. Water absorption. Water absorption is less here. This is the, I think, best one. Water absorption is less here. And bulk density. Compressive strength of tubes. Then 28 days flexural strength of prisms. This is with conventional concrete. This is with angular aggregate. Beam test, load deflection curve of the conventional material versus the angular material. The government of India has withdrawn a 8% excise duty imposed earlier on fly ash products. So government is encouraging to manufacture fly ash based products. Similarly, the import of equipment, machinery, and capital goods required for the production of fly ash custom duty has been exempted. HUDCO and NSB are extending financial support to promote industrial units for production of building materials based on fly ash products. The conclusion: the compressive strength, flexural strength, and split tensile strength for M20 grade increases with increases of fly ash percentage in concrete mix-up with 30%, satisfying the corresponding target strength, and decreases beyond 30% for this grade of concrete, M for M20. The maximum compressive strength of M20 concrete cubes are 30% replacement of 100 mm aggregates by fly ash based pellets of 100%. coarse aggregate, the compressive strength more than target strength. So it is possible to replace 100 pellets, 10 round pellets aggregates completely with fly ash based lightweight pellets. Based on the 3 beam tested on load frame, the beam sand replacement and beam with 100% pellets, so little difference of the ultimate load and the control beam, but the beam with fly ash pellets shows horizontal cracks also along with vertical cracks. Tiles, replacement of fly ash with cement and concrete tiles increase in weight transfer strength up to 20% and then decreasing for 30%. Water absorption is also decreasing and then increasing. However, it is within the permissible limit of 10%. Replacement of fly ash with cement, fine aggregate up to 30%. Increases the transfer strength and water absorption is same for cement replacement. ICBP, the compressive strength of ICBP for all these steps increases with the increasing of fly ash as a cement replacement material up to 30%. After that, it decreases. The flexural strength of ICBP after 28 days increases up to replacement of fly ash. After that, it decreases, even though decreases up to 10%. The flexural strength of 40% replacement, also more than 4.5 MPa, which is the required flexural strength for M40 grade of concrete. So it can be used for pavement material. Water absorption of paver block decreases with increase of fly ash percentage for sand replacement up to 30% replacement. From the durability studies, the weight of spalled material after 25 cycles of freezing and thawing of durability is less than 1% dry weight, means actually its durability is good. The fly ash based angular lightweight aggregate are developed and tested vis-a-vis conventional granite aggregate for its properties. The aggregates show comparable strength parameters and can be used in RCC construction. Recommendation: it is possible to replace sand and cement to be used in tiles, paver blocks, and other structural concrete members, make sustainable construction and eco-friendly environment. Paver blocks out of M40 grade with 30% fly ash to be used for pavement under medium traffic conditions. Angular lightweight aggregates can be manufactured and can be used safely in concrete construction. Fly ash, although posing environmental pollution, it's also important raw material for various applications. The utilization of fly ash in construction, removal of organic compounds, heavy metals, dyes, synthesis can help a great deal in the reduction of environmental pollution. For maximum benefit, new technologies for the utilization of fly ash should be made use. There should be greater emphasis on the development of new technology for efficient utilization of fly ash. Fly ash utilization program must be extensively taken up, covering various aspects at different level to minimize the environmental pollution. Reference, and this funding is from the government of Orissa. We could see paver block mixing, preparation of this specimen. That is the paver block. There is one more paver block abrasive. Oh, here it is. So in this way, it is done, and we need to find out how much is eroded by abrasion. So I finished my presentation. So any question, any clarification? Hello? Please unmute everybody. Any question, any clarification? Next, if you have any question, you can ask.
Participants are requested to ask any question if there is any doubt.
Good afternoon, sir.
Good afternoon.
Sir, if you're taking pellets or you're taking in the form of powdered form, fly ash, sir, if you're seeing which is more preferable, generally, which is more preferable, sir?
Which one are you talking about? Can you repeat the question?
If you're taking in form of pellets or you're taking in a form of powder, sir, powdered form. So which is more preferred?
What you like to do?
So it depends on the
fly ash. We have got it made. Round pellets are manufactured by Impa Chaudhar. That we have tested only its suitability, and we have manufactured angular aggregates from fly ash. So it depends on whether you want to use it as a cement replacement, whether you want to use sand replacement, what you like to plan to use it as. Fly ash can be used for various purposes. What you like to do. You are telling which is better, pellets or powder?
Yes, which is more convenient for the user.
If you want to like to use it as an aggregate, so pellets are already manufactured. You can straight away use it. Pellets are being sold in market. Or if you like to do, because every fly ash is different, every thermal power plant is different. Not whatever the strength we have got it, everybody will get it. In the sense, actually, he may get more, he may get higher based on the fly ash quality. So every fly ash has to be tested. Every fly ash product has to be tested. Either if it is a round pellet, it also has to be tested. If you are taking fly ash to manufacture angular aggregate or anything, or in the replacement directly, so it has to be same kind of testing has to be done.
Thank you, sir.
Do you got your answer, or you are still?
No, sir. No, sir. I got my answer. Thank you, sir.
Okay.
Any other participants?
Good evening, sir.
Good evening.
Thank you for the very interactive and very informative session. Sir, can we blend fly ash with the, nowadays the waste tire rubbers, especially the waste tires, are a big problem for the disposal. So generally in overseas, they used to use the rubber crumb for road construction.
Yes.
So can we blend fly ash and ground tire rubber for the road construction purpose?
Actually, rubber blends.
Especially ground tire rubber. Especially
that is more often used for road construction. However, studies are also done. I have got 2 theses on PhD thesis on this. For as to be used as concrete. You can use all these testing has to be done, and it can be used. But rubbers are because it has a bituminous content, so they are more used for road construction.
Okay. So for the pavers block, it's difficult.
No, it can be, you can try only. So everything can be, once I will tell, if I will do whatever test I have done, I can confirm that one, right?
Oh, okay, okay. Because I
Rubber
have
thing
heard
can be
that.
tried. So all those things people have tried with concrete also.
Yeah, some group, sir, some group has tried to use the waste plastic also to make pavers
People are
block.
trying everything. So many things are on the web. So you can always try, but whatever you try it, get it result proper mixed design. Everything has to be tried, and if you get proper strength, then it's okay.
Okay, 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 sir. Thank you.
Zoom workplace आहे मीटिंग प्रोसेस प्रोग्रेस हो मीटिंग सुरू तुमची म्हटलं हळूहळू कोण बोलाले.
So if you want to ask question, then you ask. Please don't discuss. If you have any doubts, you can ask.
Or else we will close.
Or else you will close.
हा राहू दे राहू दे.
So no more question.
Sir, good evening.
Good evening.
Sir, I am having question.
Ask now.
What the products manufactured by using fly ash, like pavers, bricks, are they fire resistant?
Fire resistant.
Pavers and bricks.
No. So fire resistant. Why it needs to be fire resistant? If it is to be used in the blast furnace linings, then it needs to be fire resistant. If it needs to be used for road construction, it need not be fire resistant.
Bricks.
Fly ash bricks. Fly ash bricks are not. It resists fire. If it is susceptible to fire, the strength will be less. It can sustain up to certain extent.
Sir, another question. Sir, can we grow plants by using fly ash?
Plants in the fly ash. People are doing that.
After composting, I think.
But it is enemy. Cultivation is becoming difficult due to this fly ash, pond fly ash. But something, it has to be mixed with some soil, this, that, and it can be grown that way. It is not like fertile land, you will get it from fly ash. It's not that. Okay. Any other question?
So I think there is no more questions, sir, for this session.
Okay. Okay.
Okay. Thank you, sir. Thank you, sir, for your valuable presentation and informative session. So I am very much happy that a professor, a teacher like you guided us in this faculty development program. Actually, I belong to Raurkela, but I did my Bachelor of Engineering from UC Burla. I think nearly about 2000 or 2001, I was staying in Sector 1 near the Shiva Mandir, NIT REC Raurkela. So once I had visited to you, sir, during 2001 or 2, and I met with you. At that time, some integrated PhD program was going on, I think 2004-5, like that. So I had discussed with you, and I had listened a lot from you, and today we got some opportunity to listen from you. This is our pleasure, sir. And at last, I thank you, sir, for your cooperation for your valuable time, for your guidance, and for your valuable information shared to all the new generation candidates. With this, again, I thank you, sir, very much. And kindly, I want to take permission from you to close this session, sir.
Sure, sure. Thank you very much. Thank you for inviting me.
Namaskar, sir.
Thank you, the participants.
Sir, namaskar.
Namaskar. Namaskar. So closing this session.
Namaskar, sir. Mosumi madam.
Hello.
Shall
Sir,
we
it
start?
start now.
Okay. Thank you, Mosumi. So, this is the last session of our 6 days Atal online faculty development program sponsored by AICT on the thrust area advanced materials, rare earth, and critical minerals. So, I am thankful to our resource person, our speaker, our guide, Dr. P. Gururaju sir. A very good afternoon to you, sir.
Good afternoon. Good afternoon to all.
So also a very good afternoon to all of the participants present in this session number 13. So before that, I want to introduce our speaker, Sir Dr. P. Guru Raju. Is currently working as General Manager, Quality Excellence Cell, Afcons Infrastructure Limited. Sir has worked with Ponch Lloyd, Adani, Dotsal, and executed infrastructure projects in India and overseas. He is responsible for the implementation of QMS and lean practices across his organization. Utilization of unsuitable soil, black cotton soil, and waste such as cyclone dust in highway construction. Sir completed his BSc BE in civil engineering and MBA in safety and also PhD. Sir is a fellow member and chartered engineer of Institution of Engineers India, certified the lead auditor in ISO 9001-2015 and internal auditor in ISO 14001-2015 and OHSAS 18001-2008. Sir has published 5 papers and is having 30 years of experience. So I welcome you, sir, to this session, and the participants are eagerly waiting for you because your last session was so outstanding. I got feedback from the candidates that really we are very grateful to this auto program and synergy to invite such type of personality. So I am very much happy to see you again for this session, sir. Now, with your kind permission, I want to invite you to start this session.
Thank you, Dr. Pankaj. Thank you very much. Like the last session, this session also I will be having some hands-on experiences, which we will be sharing it, and let us see how we can proceed. So, with your permission, I am sharing my screen now. Share the entire screen so that it will be visible to everybody. Is my presentation visible?
Yes, sir, it is visible.
So I will be closing my video because that is creating some issues in the last time also. So this time I will be closing my video so that at least the transmission will be perfect.
Okay, sir.
So I was into the end of the last session also, which was taken by Professor Shishir, and I could hear some of the questions related to fly ash, or because fly ash comes in different forms. So in this session, though it is not covered in the presentation, but I would like to throw some light on that so that the clarification will be much better. Fly ash comes in 2-3 forms. Like one is used directly in the cement manufacturing. The other, we use it as a replacement of cement in the construction industry. And the third part, which is a waste, we call it as a bottom ash, which is being stored near the thermal power plant, and that is being replaced as a embankment material. So these are the flow of the fly ash being generated from the thermal power plant, because the output of this thermal plant is the input for your cement industries and the construction industries. So the objective of this session, we will touch upon slightly about the road types, the recent press releases, the current situation, the challenges, and how these challenges are being addressed through either through alternate mixes or through alternate materials. So again, we know that there are different types of roads, starting from rural road to state highways, national highways, and expressways. If you remember in my last presentation also, I covered a little about the type and the definition of the road types. Now, the beauty is nobody is comfortable with the state highway or the district roads. Everybody is looking for an expressway because that is what something is adding value to their daily life. So if you remember DND, the Delhi was India's first expressway being constructed, followed by Mumbai-Pune expressways and the Mumbai-Nagpur expressway, which is covering almost close to 700 kilometers. And if you travel in that particular road, these 700 kilometers can be covered within 6 hours, 5.5 hours to 6 hours to be precise, because last month only we had the opportunity to travel from Mumbai to Nagpur. And though it is perfect ride if you think of. So once you travel in such roads, you don't feel like traveling in a single lane road or a 2-lane road. And during some of my travel experiences, we used to see that there are still some national highways which are 2-lane. So that gives a strategic difference between the 2-lane construction, the 4-lane construction, the 6-lane, and then the 8-lane constructions. So as the roads becomes wider and wider, the speed goes higher and higher, and the risk of accident goes on higher and higher. So the recent press releases, if you see, the Indian National Highway records 60% growth in the last 10 years to become the second largest road network in the world. Though it keeps the second largest road network in the world since its inception, but in terms of expressways and the quality of the roads, the transportation times, it has been developed a lot as compared to the year back 2014 or 2012, when you don't have much opportunity to travel by road. Recently, if you see the Ranchi Jamshedpur Expressway, it drops from 5 hours to 2 hours. The travel time drops from 5 hours to 2 hours. In Ladakh, if you see the increase in the road quality, the construction is close to 31 kilometers of road, and upgradation of these roads made these roads weatherproof and all weather accessible roads, especially the Rotang tunnel, which is being constructed by us in the valley. So it is basically connecting, because in the absence of those tunnels, what happens was during the winters, because of the high snowfalls, you are not able to travel from this end to that end, basically from Manali to the Ladakh region. So that particular project, the Atal tunnel, was the connector between the Manali and then the far end of the Ladakh regions. So few highlights, if you see, as of March 31st, 2025, India has constructed more than 63 lakh kilometers of road network, out of which national highways are to the tune of 1.5 lakh, 1 lakh 46,000 kilometers, state highways 179 and 60,000 kilometers. India being the second largest in the last 11 years, if you see, it has amplified by 54,000 kilometers in terms of national highway construction. National high-speed corridors, if you see, from 93 kilometers, it went up to 2,500 kilometers. And there has been a 570% increase in the road sector budget since 2014, from 2014 to 23-24. It's because of the increase in the budgets you are able to see the activities going on in the field. But it has got no impact on the cross-section of the roads being built. Like the asphalts have been moved from DBM to, say, SME constructions, and wearing courses are being little more advanced as compared to the wearing courses. But still, the embankment, subgrade, GSB, WMM, all these sections are being similar to what is being there since 2014 onwards. Now, the problem is the availability of the material. With the increase in the speed, you have the increase in the demand of the materials to be used in the construction of road. That's exactly what we had talked about in my previous presentations also. So this is the particular slide which we have discussed in my previous presentation also. If somebody has missed out, he can just get an idea about what is the demand of the materials per kilometer for a 6-lane road, and then with the increase in the speed of construction, what will be the increase in the demand of the material. And that is exactly what we are talking about, the requirement or the need of an alternative material or an alternative mix which can address which can reduce the need of the materials, naturally available materials. When we talk of materials, it is basically the naturally available materials. So in short, if you see, when the speed of construction increases, it improves the connectivity, it improves the better riding quality, it reduces the travel time between the 2 points, and also reduces the dependency of individuals on the public transport. Now, these are the advantages of the speed of construction, speed of connectivity, but at the same time, there is an increase in demand for raw materials to be constructed these roads. So this is basically the challenge in the road sector these days. Because of the increase in the demand of the materials and drop in the availability of the suitable materials, you need to address how you are going to construct a good road, a quality road, which will be defect-free for its design life. And this is exactly what gives you or allows you to look for the research areas, look for alternative materials available, and also reduces the use of naturally available materials like aggregates, cement, soil, etc. Soil part broadly we have covered in my previous sessions. So now this time we will be covering the section which is above the subgrade levels. Now, when we talk of GSB and WMM layers, you have the earthwork in total. You have the naturally available materials, which is available with respect to the suitability. So when we talk of suitability, that means there is a check which needs to be confirmed with MORTH requirement clauses. So the alternative materials which we worked on is the coral sand, which can be used in GSB or WMM to replace the fine aggregates. The steel slag, which we are used in WMM to replace the coarse aggregates, especially the 40 mm aggregates. The cyclone dust, which is again, this is a byproduct of your hot mix plant. The waste generated from the hot mix plant is what is known as the cyclone dust, can be used in earthwork. And then the best is the legacy waste. Legacy waste is nothing but the waste, the society waste being dumped on every corner of the city and accumulated at one place. Those are the waste which are being, over a period of time after the decomposition, can be segregated and used for earthwork. This is a project being taken by the PM supports, and the CRRI was actively involved in studying the legacy waste of Gazipur depot, which is placed in Delhi. So I was fortunately I was part of that project, and we are supposed to do a trial patch. But before that trial patch being done, I was out of the picture. But then the testing and everything we can discuss there. Now coming to the first section of the material, that is the coral sand, which we have used for road constructions. The coral sand is basically available in the seashores, and we have a project in Maldives, which is an island connected all the sides by water. So it is very difficult for the project to execute that area wherein there is a lack of availability of good materials. Now, in that particular project, we generally transport all the aggregates from India, that is from Gujarat to the port of Maldives, store there and do the construction activities there. Maldives, as you all know, is a set of islands, more than 1,000, more than 100. So Malé and Adu City are the two areas where we work. In Maldives, we have one road project and the other one is the bridge project. In this particular case study, we will be discussing about the internal roads being constructed in the Adu City. Just let me use the pointer so that this is the area which is called Adu City, commonly called, and this is where wherever the land is, exposed land is there, they have the roads to be constructed, and this is being constructed using the naturally available coral sands, which you can see on both the sides below, within the water locations. Now, the challenge here is basically the demand of the materials, the cost of transportation of the good materials from India to Maldives, the supply constraints depending upon the availability of the ships, the availability of the material, the containers, and then of course it again depends upon the weather conditions to transport the material from India to Maldives. Because of the remote location, there are other issues also like loading, unloading, and then storage. So it gave us an idea, okay, why can't we try the naturally available materials which can be used some part of the road sections. And we, because in that particular road, we have a CTB layer, the cement treated base layer, and we try to use the coral sands in the CTB. As you rightly pointed out, necessity is the mother of invention, and this is exactly what went right in this particular case for coral sand, that uh, we tried to use it because there is no other option available. We don't have any other option but to try and test the naturally available material for their suitability as far as the contract specification is required. So this is the section of the coral sand which is available in that particular region. When you dig around and this is giving you an indication that it is a mixture of the fine and the coarser materials, and only thing is that needs to be processed in such a way that it will become suitable for my either GSB or WM layer. So what we have done is that the cement treated base, the mix of the cement treated base was introduced with coral sand and see what exactly the properties are and how this is meeting my requirement. Now, this is the filtered processed coral sand which was available there in Hulhudu city, which is near to the Adu city. This is the location of that city, and this sample was collected in 2024. And this is the material which is being introduced into the cement treated base layer. Whereas the demand for the cement treated material was close to 136,000 metric tons, and since the requirement is more, so the replacement will add value to these particular areas. So basically, two things which the forum needs to understand is whenever you think of an alternative material, you need to think of the scope of the material, the total requirement of the material, because there should be a point, there should be a value addition to your research or to your understanding that when you are working so hard to check the suitability of the materials, then at the end of the day, that needs to be benefited in terms of the monetary benefits also. Had this been only say 10,000 metric tons or 20,000 metric tons, then there's no point of working in that direction unless you have the zero availability of the natural materials. So since the requirement is huge, so the transportation of the material will become huge. And so that is what is made us understand that it is worth going for checking the suitability of this particular material, which is available free of cost there. So what we did is we checked the gradation and all other parameters and the MDD requirements. And if you see the tables given on top, the initial mix design, the conventional mix design was including the 10 mm, 6 mm, and then the stone dust along with the cement. But when we talk of coral sand now, the complete 10 mm, 6 mm and stone dust, that means what? It's close to 137,000 of that material is completely eliminated and use just the coral sand, 97% of coral sand and 3% of cement. So because my original mix, the conventional mix of CTB is introduced 74% of the stone dust only. And since the coral sand is having maximum of stone dust, so that gave us an indication that this can be used as an alternative source. And the beauty is during the test, it was understood that coral sand contains some part of silica also. That means which has given the opportunity to even reduce my cement content from 3% to 2%. Though in the project we have not done that because it was again by the time it was recognized, it was too late to change the mix design. But when you get an opportunity to do such trials, please look at the possibility of reducing the cement also, because if you see the pure soil, and when you add cement to the pure soil, with the increase in the soaking period, your CBR value goes on reducing. Like any soil you take, any soil of your choice, and we normally conduct 4 days soaked CBR test to compare it with the requirements of the standard or the most requirements, whichever is given in the standard. But what will happen when you increase your 4 days soaking to say 7 days, 10 days, 14 days, or 28 days? So when you do the soaking, increase in the soaking period, your CBR goes down. In case of soil, if you increase the soaking period, your CBR goes down. But that exactly what is not happened in case of a coral sand. In case of coral sand, if you increase your soaking period, your CBR goes up because of the presence of the silicates in the coral sand. And this we could justify or identify by doing some chemical test to understand the composition of the coral sands. So if you see the graphical representation, the parameters like CU, plasticity index, liquid limit, MDD, and UCS. UCS is ranging between 2.5 to more than 4. And with the increase in the cement content, say 2.5, 3, 3.5, 4, and above, you can see that my basic minimum UCS is achieved with 3% of the cement doses. And of course, the density, the maximum dry density is well in the range of what is being achieved using the normal conventional mixed designs. There is no much variation in other parameters. So that gives you an indication that in the absence of the coral sand, you are able to achieve 20% PI, but with coral sand, you are able to increase your PI values with the increase in the cement content. So this is the table which gives you the idea, yes, that your coral sand, even if you replace the naturally available aggregate that is 10 mm, 6 mm in stone dust in this particular place with complete coral sand, your parameters, the engineering parameters are not changed or not compromised, and you are able to achieve the required values. So those things can be produced and used in the field. Now, when it comes to field, it is so instead of 4 proportions to be blended together, you have only 2 proportions to be blended, that is coral sand and cement. Instead of 10, 6 stone dust and cement blending, you can blend the coral sand and then the cement. So the processing time has reduced a lot as far as the mix is concerned. So spreading of coral sand, adding water to the coral sand, and do the mixing, do the harrowing using the grader, and then spread it, the cement required using either manually or RM300. Then mixing of the road, mixing of the material on the road with rotavators will add pulverizations. The better the pulverization is, the better the mix is, and the better the uniformity of the test results being achieved during the lab conditions. Because the basic difference between the lab trials and the field trials lies in the pulverization area, because other things remains the same. You can control the quantities by measuring it mechanically, but when the spreading is being done, when the mixing is being done in lab conditions, you have better control. In the field, you may or may not have the better control. So to ensure the control on the mixing part, the rotavators and the pulverization activity using the rotavator needs to be perfect, and then do the rolling part and then the testing to ensure that you achieve the required density. Of course, thereafter you have the curing period to be maintained. Generally, in this particular case, we have used 7 days curing using either the sand bed or sometimes with a polythene sheet covered with water. So that is giving you an idea. Yes, you can replace the coral sand for a particular layer in the city roads at one of the projects in Mali. So now what helped the project in terms of cost, in terms of process cost, or in terms of the material cost? Now, in terms of material, when we talk of, you have completely eliminated the use of the aggregate, which is supposed to be transported from India. So, and you are using directly the available materials, which is free of cost, which is close to 9 to 10 crores, and the process time also is being reduced by 90 days, which is being estimated to be close to 15 crores. Now, when you talk of process time, how do you calculate the process time and how do you calculate the material cost varies from process to process and location to location. In this particular case, when you talk of process cost, the process of intermixing of 10 mm, 6 mm and sand dust is being completely eliminated. So you don't need to mix and prepare a stockpile and test it for its suitability. Rather than you can directly lay the coral sand which is available there and then mix in the then do the infield mixing of the cement and do the other activities. And of course, there is a reduction in the CO2 emission because of the reduction in the use of the naturally available materials. So in total, if you see, if you apply the conventional method and the alternative method, there is a net reduction of the CO2 by 100%. Now, the next possible material which we can use is steel slag in highway constructions. Steel slag, the test trials are being done by CRRI in Baroda Halol Road also, if you remember correctly. But the availability of the steel slag is, of course, an issue as far as Indian projects are concerned, because I have faced such difficulties here. But unfortunately, we get the opportunity to use the steel slag in one of the projects in Bangladesh where it is available in plenty. And in that particular project, the GSB mix was being chosen to replace the aggregates, 40 mm aggregates of the GSB mix using the steel slag. Now, when we talk of the naturally available lack of naturally available materials in Bangladesh, but a particular project in Bangladesh. So again, in Bangladesh also we used to transport the aggregates from India only, and then that adds cost to the transportation and to ensure the suitability of the aggregates. So the idea of using the slag, steel slag, which was available there in Dhaka, close to Dhaka, in one of the industry, is identified and then tested the suitability of that particular material. Now, it gives you an idea that the cost of the material, if you use the steel slag in WMM, it reduces by 2% per cubic meter, and the carbon saving is close to 18% per cubic meter in this particular case. Now, what type of aggregates are available, and what was the properties of these steel slags which is being used in this particular project? If you see the properties of the steel slag aggregates itself, the LA value is close to 25%, ACV is 20%, TF is 223 kilonewtons, specific gravity is close to 3.01, water absorption is 0.49, which is very less, unless you choose a porous aggregate. Soft fragments are less than 3%, and the potential alkali silica reactivity is innocuous. Now, when you check the mixed properties using the steel slag, mixed design of subbase with the natural aggregates, the MDD was close to 2.338, whereas if you replace the 40 mm aggregate if you replace the select natural aggregates and by 40 mm steel slags, again the slight drop in the MDD values, but it has not deteriorated the properties of the mix, because the CBR has moved from 114 in the natural available materials, use of naturally available materials, to 129 in case of steel slag. Now, if you see the construction steps or the activities being incorporated, you need to have a stockpile in place, which will be in combination of the 40 mm slag, and then the material from the stockpile can be transported to the site using the dumper and dumped at site, and then you can do the grading and rolling operations to prepare the finished bed like this. This is a GSB bed, which is composed of steel slag aggregates. So, in short, if you see, the only challenge what we have faced in steel slag in particular is there are particles which have surface voids, as shown in the left hand side. These type of aggregates, if the intermixing of these type of aggregates will deteriorate the properties of the steel slag, because these are soft and these are being created because of the lack of the cooling operations. So there needs to be a perfect quality control, which will give you always the aggregates which is having less porous surface on top of the steel aggregates, as shown in the right hand side. And then the second is, even today also, the pressures are because the particles which is available is only of 40 mm size, and people are still not getting it. Hello. Yeah. Any questions you have? Okay. So the limitation in the availability is the size of the steel slag, which is 40 mm, and lesser size are expected in future as we grow in the technology form, so that the complete aggregates, if available near to the steel plants, can be used using the steel slags. Now, the third point which we want to touch upon is the cyclone dust or the baghouse dust, which is available within the construction projects and can be used in the highway constructions. Now, cyclone dust is basically a waste or a byproduct of the hot mix plant. If you see the photographs, this is a particle size of the cyclone dust is less than 75 microns, and it is a waste and difficult to control or control its disposal. So it is having the environmental impacts also. So generally, the storage and the applicability is being tested in this particular study. Now, if you see the requirements of MORTH, the lab densities for embankment, you have 1.52 grams per cc is the minimum density required, and for subgrade, it is 1.75. Similarly, liquid limit plasticity index, free swelling index, density of the compacted layers, and then the CBR for in case of subgrade, it is minimum 8%. So that's exactly what we touched upon in my previous session. Like whenever, even if you have a CBR of less than 8%, you can stabilize it and reach to the minimum or the maximum requirements. Now, these are the samples of the cyclone dust in one of the projects. You can see the fine material. This is directly being dumped into the manual sump created and close to the hot mix plant. One second. Or else, alternatively, it can be stored in the silos also. Now, the transportation of such a fine material is a challenge for the construction industry also. And once it is being stored with water, once the water is being mixed with this particular slab, the color of this complete material looks like a slush. Now, the idea is to test the material for the different properties which is being given by MORTH. Like we started with the Proctor test, the density test, and then followed by the free swelling index using 2720 part 40. And then you can do the liquid limit test by cone penetrometer, and then of course the CBR test of the cyclone dust. The beauty is any material, if you want to check, if you want to use in any layer of the road construction, you need to first check the suitability of that material based on some requirements which is being given by MORTH. Now, if you see the average properties of different samples, we have tested close to 12 samples from different projects. And if you see the properties of the cyclone dust or the baghouse dust, the sand content is close to 13%, the silt content is close to 80%, the clay is 5.3%. Average liquid limit values are 28.7, plastic limit is non-plastic, FSI close to 6%. The density, the Proctor density, standard Proctor density is above 1.52, and OMC is 14%, and the beauty is the CBR is more than 25%. This gives you an indication that this particular material, which is a waste generated from hot mix plant, can be used as a construction material either in embankment or in subgrade layers. But the problem is the use of that material by the time, because if you see any project, the start of the project, this material is not available. By the time 50% of the project is over, the asphalt work starts, but still there are a few sections wherein you can go for these materials. So wherever the approaches are there, wherever the new material, new earthwork needs to be done in the project, once you start the hot mix plant, you should be able to store that material in the safe zone and try to use it there only so that the disposal issues can be resolved permanently. So these are the 12 different sites from where we are able to capture the samples and tested the material for their suitability, and average of these materials are being discussed in my previous slide. Now coming to the next material which was tested was the legacy waste. Legacy waste is basically nothing but the waste material, the city waste, which is being dumped in outskirts of the cities and which gets piled up in such a way that at this point of time now the control on these materials itself is a challenge. Like Delhi is surrounded by 3 to 4 such piles, which is height, which wherein the height of these materials is more than 80 meters, 70, 80 meters. So the as the population goes up, the quantity of the disposal is goes up, but at the same time, the storage restrictions are there. Storage is limited. So there is a need to look at the use of these materials in different other areas wherein we can use and try to control the storage locations. Now, the method which is adopted was the screening method. The initial method was adopted as the screening method, and that particular waste after screening, you can get the final product, which is a fine material. And there are two ranges of materials which comes out from this processing of the legacy waste, which is 6 mm down and 13 mm down. Now, when you talk of 6 mm down and 13 mm down, the idea is you can release. There are equipments available which will which will give you the option to remove or separate out the polythene sheets separately, the concrete debris separately, and then you can get the fine particles separately. So these are the processes being adopted and then being tested to see its suitability for the use in the earthwork. They have they are supposed to do the leaching test in the field also, but fortunately I was not a part of that particular process. But definitely this is a material which has a potential, which has a scope to be used in the underneath layers of the roads and highways, especially the embankment part. So if you see the storage part, because these are properly channelized and treated materials, and you can see the output of these materials, which looks like the sand from a distance, but of course it has been purely a sand part only. All the fine particles and the other debris are being segregated separately. So the different types of materials, 2 3 components we can achieve after the segregation, which can be stockpiled and then used at different layers. So these are the initial processing photographs, wherein you can see that the material which is able to fly off, like the polythene sheets or the other pieces which are lighter in nature, are being removed temporarily, and then you can get the material which is required for. So close to what the study being conducted by CRRA was indicative, there is a potential to use these materials to ensure that you don't run off by the storage of the materials. And at the same time, there's nothing called waste in the industry. Everything is usable and recyclable. The idea is, the problem is, we should be able to understand, we should be able to make a framework in such a way that these unusable or waste materials can be developed in such a way that these materials can be used. Now, once the material part is being covered, now I would like to touch upon the alternate mix types. Like when we talk of alternative mix type, there is no direct impact on the material part. There is no direct saving on the material part, but of course you have a lot to save as far as the environmental and the CO2 emissions of a particular project is concerned, the life or the durability of the mixes are concerned. So indirectly, if you see if the durability of the mix is enhanced, if the defects in the mix is reduced, if the operational controls can be strengthened by increasing the by increasing the durability of the mix, then definitely the repair or the defects will be less and rework can be minimized, which will have a lighter alternative source to understand and ensure that these mixes can be used. So what is the alternative mix which we are supposed to use, and what do you mean by WMA? WMA is nothing but warm mix asphalt. When we say warm mix asphalt, it is a mix of asphalt which is neither hot nor cold. So the production temperature lies in between the hot and the cold mixes. As you all know, we have hot mix asphalt, which we are talking of with a production temperature ranging from 150 plus, and you have a cool asphalt also, which is being prepared using the emulsion and normally used for patch works and the repair works. And this is a mix which is being used for the new construction, but the production temperature is less. So if you see the different types of asphalt, you can see a cold mix asphalt wherein the temperature is maximum to 50 degrees, and once you reach the temperature above 50, it slowly converts into half warm mix and then uh, warm mix, and then you can say from 150 onwards it is being categorized as hot mix. Now, the beauty of see, we all know that the bitumen is temperature susceptible. The more the temperature is, the better the mix is. This is a general tendency or the general concept being taken or being addressed, being adopted by everybody. If your mixed temperature is better, if your mixed temperature is good, you have the better operational controls and you have the better wider envelope to go for the laying and the production laying on the compaction sites, and you will be able to sustain this mix higher. But that is something which is not correct. Again, the mixed temperature is depending upon the type of the asphalt being used, because we are being using like say 2030 binder, which is normally not here in India. But if you look at the French specifications, they have 2030 grade binders also, wherein the mixed temperature is close to 190 degrees. It's neither 150 nor 100, but it is close to 190 degrees if you are using the only 2030 grade binder. In case of VG40, you have a mixed temperature close to 155 to 160. So VG30, VG40, or if you are using a PG grade or a PMB grade, the mixed temperature is changing little depending upon the softening point of that particular mixes. This is what is I have understood as far as the asphalt is concerned. So the idea is, how do you control the mix temperature without compromising on the mix quality or the mix workability? Now, to ensure that the mix is workable even at a low temperature, the technology which come up, not new. This is not new in the global industry, but of course in India, it started popping up since 2010. So since 2010, I was into this particular subject, and I was looking at the ways and means to use in one of the projects. But fortunately, I could get the opportunity to use this particular mix in one of my overseas project in Africa, which is Gabon. There, because of the French specifications, we are able to use this mix as a warm mix asphalt. Now, warm mix is a mix wherein by adding the additives in the asphalt, by adding the additives in the asphalt, you can play with the workability of the mix. You are not playing with the properties of the asphalt, but you are not changing the properties of the asphalt, but you are playing with the workability of the mix. Meaning what? If you add the additives and if you mix that in the hot mix plant, though you are not controlling the temperature, you are bound to control the temperature over a period of time. This is the practical experience. I am sharing it with you because we have done that practically. By adding the warm mix additives also, we have not controlled the mix temperature. We followed 190 degrees mix to be laid in the field. The problem was, once you laid in the field, the temperature was not reduced to the required rolling temperature even after 3.5 hours to 4 hours because of the additives. Because by adding these additives, what happens is it increases the ability of the binder to coat the aggregate, and also the controls the rate of loss of temperature in the mixes. So then, fortunately, we have no option but to reduce the production temperature by 30 degrees. And fortunately, if you see, because if you are not reducing the temperature and rolling it at a higher temperature, the waves will come on the surface which is not visible to you. And once the mix cools, once the mix gets cooled, you can see the waves, which is generally noticed during the test called the profilometer test. So this was the difficulty if you're not able to control the temperature by adding the warm mixers. So the crux of this discussion is, if you are adding an additive which is supposed to control the mix temperature, and you are not controlling the mix temperature, because there are other advantages also for that particular mix, like it also gives you the increased moisture resistivity of that particular mix. But if you're only focused on moisture resistivity, and by adding an additive you're not controlling the mix temperature, you will end up with the riding quality. So those things we will touch upon slowly. Now the definition part, if you see, the hot mix is generally in the range of 160 to 180 in Indian conditions, but it goes beyond 180 in overseas, especially when you refer to the French courts. And the warm mix temperature goes 30 degrees minus to what your hot mix temperature is. In this particular case, you can go from 30 to 35. So in this particular temperature, you can range your warm mix temperature from 100 to 135 or 140 max, but not above 140, because if you are taking it above 140, your compaction temperature requirement, which is close to 120, less than 120, you will get difficulty in rolling it. When it comes to half mix, the heated aggregates at a mixing temperature of 70 to 100 degrees is what is being developed, is known as half mix, half warm mix. And of course, the unheated aggregates, when being added to emulsion or the foam bitumen, you call it as the cold mix asphalt, which is generally used for repairs and patchworks. So when you talk of hot mix, we have used the material called Evotherm, which is an additive used to control the moisture susceptibility of the mix. And moisture susceptibility is a test which is basically based on the type of the aggregate. And if your aggregate is moisture susceptible and you don't have any other option but to lay it, then it's always good that you should use Evotherm as an additive in the asphalt, which will coat your aggregate in such a way that this particular test will never fail. And then the temperature management due to higher lead. If your lead time is more, and if you want to maintain the production and maintain the laying temperature, maintain the rolling temperature, it's always a challenge in case of a hot mix asphalt, and you burn the asphalt in order to meet these such challenges. So those things can be avoided if you are using a warm mix asphalt. And the third one is a lower ambient temperatures. So when your ambient temperature is low, or when your mixed temperature goes below 100, even below 100 with less compaction efficiency, also you will be able to compact a warm mix asphalt as compared to the hot mix asphalt, because hot mix asphalt, the workability of the mix drops once you mixed temperature goes below 100. And that is the reason why in the standard says your rolling temperature should be closed before the mixed temperature reaches 100 or 90, depending upon the type of the binder being used in the asphalt mixes. Now, whenever the borderline performance values are there, it's always when your fatigue or the rutting test results are borderline, it's always better to use for the performance additives also, which will be used in combination with the Warmix asphalt. Now, this in total will give you a sustainable, durable payment and performance by adding the Evotherm and then the performance additives. Performance additives like PR module and PR plus, which are like pellets in structure, bituminous and wax-based materials, but generally not used in India. But this particular case we have used in one of our African projects, which is being shown here. Now, when you talk of additives, coating ability is enhanced. You can lay the product, you can produce the mix at a lesser temperature, typically 30 degrees less, and then it can be more workable. If you see the photographs, the normal aggregates, the uncoated aggregates, and then the coated aggregates, this is basically the deficiency, basically the effect of the Evotherm mixed in the asphalt. So if you compare the Warmix asphalt and then the hot mix asphalt, generally what happens is the bitumen is heated to a sufficiently high temperature to make it fluid enough to surround the aggregate and coat the aggregate surfaces. But in case of Warmix asphalt, what happens is the volume of the bitumen is increased by the additives, by making the bitumen less viscous and reducing the surface tension at the aggregate's surface level and bitumen interfaces. So basically, the coating ability of the asphalt, coating ability of the bitumen is enhanced by adding the additives in the mixes. So if you look at the needs and benefits of the Warmix asphalt, you have the environmental benefits. That means it reduces the GHG emissions by 25 to 30%. It has the health benefit because of the to the construction workers, because these are the workers who have to deal with a high temperature, and by adding Evotherm or by adding any of the additives which can be used to reduce the mixed temperature, the workers working around the paver will be more comfortable as compared to the hot mix asphalt. It improves the workability of the mixes. It reduces the rate of loss of temperature. It increases or enhances the compaction ability of the pavement, which is resulting in the long-lasting pavement, delayed fatigue cracking, reduces the oxidation and aging of the bitumen, and better cold weather construction opportunities, and permits you to haul for a longer distance. These are basically the benefits of using a warm mix asphalt in case of a hot mix asphalt. Now, when you talk of the different types of technologies, there are water-based technologies, there are chemical additives, there are rheological modifiers, and there are hybrid technologies available in the market, which will turn your hot mix asphalt into a warm mix asphalt. And when we talk of warm mix asphalt, please remember that when you talk of warm mix asphalt, your production temperature needs to be reduced by 30 degrees to your conventional hot mix temperatures. And unless you reduce the temperature, you will not be able to achieve the complete advantage of using the warm mix asphalt. When you talk of chemical additives, it has got little effect on the rheological properties of the binder. Directly can be added to the mix or the binder, but generally we go for the addition in the binder itself. There are surfactants which reduces the surface tension between the aggregates and the bitumen, and you have 0.2 to 0.75% by weight addition. The doses of Evotherm ranges between 0.2 to 0.75 depending upon the type of advantage or the type of advantage you normally want to take. So generally, if you go for a 0.4 dose of these additives, you can reduce your production temperature by 30 degrees, and you can reduce your compaction envelope by 20 to 25 degrees. And of course, you can reduce your rolling efforts by 2 to 3 passes as compared to the conventional rolling methods. Generally, when you talk of the conventional rolling of hot mix asphalt, you go with a plain pass first, followed by 3 vibrations, low, medium, and high, or high, medium, low, depending upon the trial patch and the aggregate types. And then again a plain pass followed by PTR and a plain pass. So now what happens in this particular case is you can do the plain pass, you can do the medium vibration, and then immediately you can go with the PTR. There is no need of 3 passes of the compaction, because the PTR will take care of the rest of the job, because the mix is workable in such a way that it gets cushioned formation, and it gets better compaction, better consolidation, in fact, as compared by using the PTR. So use of PTR is more effective in case of warm mix asphalt as compared to the vibratory 10-ton vibratory rollers. When you talk of rheological modifiers like wax base, some of the components like Sasobit is available in the market, wax-based products, which improves the lubrication by reducing the viscosity of the binders and increases the stiffness of the asphalt mixes. So this is again a binder which can be used. So these are the only 2 methods which we will be discussing, but in detail you can talk of chemical additives, which is having a hands-on experience for me. Now, if you see the requirements of the warm mix asphalt, you can refer to IRC SP 101 2019, which talks about the guidelines for warm mix asphalt, wherein you can find out different types of additives which can be used for warm mix asphalt. And believe me, these mixes are better as compared to the hot mix asphalt because of 2 reasons, in my opinion. Because it gives you the comfort to operate, it gives you the comfort to operate at one point of time, and then it helps you to maintain the workability. And so the any workmanship error, because when your dependency is on the workers being deployed at site, there is bound to be a error by a group of workers, and so those errors can be eliminated completely by using the warm mix asphalt, because you don't have much to do with labors. You have only the equipments which should be in place, and any small temperature delay or any delay in laying process will not negatively impact your asphalt payment or the durability of the asphalt payment. So when you talk of the coating part, you can see those details in nature. Now, in totality, if you see, the warm mix asphalt helps you to address 3 things. One is the moisture damage of the aggregates. If the aggregates are susceptible to moisture damage, then it will lead to raveling and then the scaling. And then, of course, which is further developed into block crackings, thermal crackings, and the fatigues. And also, it addresses a lot about the deformation of the rutting formations also. But the rutting cannot be addressed if you are not able to reduce the temperature of the mix, because if you're not reducing the temperature of the mix and allowing the rolling operations at a higher temperature of 160 to 170 degrees, then you will have an envelope during the initial rolling stage only, because of the presence of the tires, and then you will get the rutting at a later stage. So these are the few things which you need to be considered, which you need to take care during the operation of constructions. And when you talk of quality assurance and quality controls, the WMA shall be the same as HMA as specified in IRC 11. But the additional test, the warm mix as for mix design, the coating ability, the compactability, and the moisture susceptibility needs to be checked upon. The proposed job mix formulas for warm mix asphalt must be evaluated for fatigue cracking resistance before the construction approval, and if wax base is additive is used. Warm mix additives can be used with all mix types like BC, DBM, SMA, especially in case of SMA. What I feel is in SMA, you normally use the cellulose fibers also, and those cellulose fibers are addressing your drain down test because of the higher content of the binder. But if you go for a warm mix asphalt in SMA, you don't need to add the cellulose fibers because of the reduced temperature. The possibility of the drain down will be less in case of SMA if you are going for a warm mix instead of hot mix. And you can always check these things with the lab trials when you conduct the asphalt mix design, and check the volumetric properties before the field applications. So these are the process or the method of the design steps to be conducted during the asphalt mixes. Determine the properties of the mix without additives at a conventional temperature. When you say conventional temperature, it is the temperature given for a particular type of binder. Like in case of VG40, if it is close to 160, in case of VG30, it has to 165. So that means what? Okay, you need to work on your warm mix temperature based on your conventional hot mix temperature, because the same mix is getting converted into warm mix by adding additives in the binder. So VG40, if added with Evothum, can be converted into warm mix, and then in that particular case, if you are adding that in your lab, your mix temperature should be reduced by 30 degrees centigrade, and then determine the properties of the mix at that reduced temperature, like aggregate coating, compatibility test, and then the moisture sensitivity test. So if you see the aggregate coating at a reduced temperature, say the first was 162 and the second was 130 degrees, maybe you will not be able to view it completely, but I will zoom it for you. So is the photograph visible? So the mix temperature here is 130 degrees, and when that some particular mix was shown, one second. Hold on for a moment. Yeah, when the same mix was introduced to the aggregate, heated aggregate, and see the coating should not be less than 95% at a lower temperature, mixed temperature of at a lower temperature of 30 degrees. So if you want to calculate the percentage coating, the number of completely coated particles divided by the total number of particles taken for testing multiplied by 100 will give you the percentage of coating, and that percentage should not be less than 95%. Similarly, when you talk of compatibility, you can prepare the specimens using HMA, then prepare 3 more samples using 30 degrees less temperature, calculate the specific gravity, GMB for HMA and WMA, calculate the maximum specific gravities, GMM for HMA and WMA, calculate the air voids, VA for HMA and VMA, calculate the ratio of the air voids, that is VA divided by VA of WMA by VA of HMA. Now this ratio should be in the range of 0.9 to 1. That is what is basically needs to be checked, and that can be done by varying the percentage of by varying the doses of the additives. Now if you see a trial which is being shared, this is particularly the doses of the Sasobit material, which is in the range of 1.5%, 1%. And if you see the aggregate temperature, the first line is talking about the number of specimens being casted at optimum binder content of 4.2%, and your aggregate temperature is varying from 160, 130, 100, 130, and 100, and then your bitumen temperature is also 160, 130, 100, and 130, and then 100. Now the idea is when you change the doses of the additives, what will be the effect on the stability, flow, coating, GMM, GMB, VA, and what is the ratio we are getting. So if you see the top three combinations, wherein you can see the aggregate temperature is 160 degrees, or aggregate temperature. The first one is the hot mix asphalt, which is giving you a VA of 4.2. This is the controlled condition. Now you have reduced to 130, the mixed temperature reduced to 130, and the doses of the additives as and the doses of the additives as 1.5%. Now, this dose of additives of 1.5% is resulting in air void of 4%, wherein it is giving you a ratio of 1, which is in line with 0.9 to 1.1. Similarly, if you are reducing the temperature, aggregate temperature to 100, and your bitumen temperature to 100, and you are adding sassobit, similar dose of 1.5%, the stability goes down a little, the flow increases, the coating ability has no change, the GMM is slightly increased, GMB has slightly reduced, the air voids are slightly increased. The increase in the air void indicates that there is a possibility of reduced compaction during the construction phase, and then the ratio is 1.1, which is touching upon the maximum limit. So if you see, for all practical purposes, your mix, the hot mix which you are supposed to use is 130, 130, thus row 2, wherein your value is 1. So if you are reducing the sassobit doses from say 1.5 to 1%, you can see that your compatibility test indicated a value of 1.2 and 1.6, which is not meeting the requirement of the specification that your air void ratio should be in the range of 0.9 to 1. So your controlling factor is the air void ratio when you are comparing your mix, when you are converting your hot mix into the hot mix, into the warm mix as well. So the method of mix design remains the same, the test remains the same, but the mixing abilities, the temperature needs to be changed and corrected, and you need to see the parameters which will be in the form of 0.1, 0.9 to 1.1. So this air void is basically giving you an indication what should be your optimum doses. Now, if you do the further trials by reducing the doses from 0.1%, like 1.4, 1.3, 1.2, 1.1, you will get an idea like in case of 1.4, if my temperature is 130 and 130 and reducing my sassobit doses from 1.5 to 1.4, what will be my ratio, air void ratios? So it will be close to 1.01, 02, 03, 04, or 05, or 09, or 1. So that is giving you an envelope. What will be my optimum doses of the additives which can be used to convert a given hot mix into a warm mix. Similarly, when you talk of moisture sensitivity test, warm mix additives are also known as anti-stripping additives. This can be conditioned and unconditioned. You can go for the TSR test. TSR test will give you an indication that your aggregates are moisture susceptible or not. And warm mix additives are a good anti-stripping agent. So this is the added advantage of converting your hot mix into a warm mix, especially in areas where your aggregates are susceptible to anti-stripping agents, where you need to use an anti-stripping agent in order to make sure that your asphalt mix meets the requirement of the TSR. So in that particular case, if you are using warm mix, your cost of other additives like anti-stripping agent or lime in particular can be eliminated, and the cost of the warm mix additive alone will add value to your anti-stripping cost as well as your production cost. So from the practical data, data which we have observed in the field, using the analysis of the production details of month on month from April to September for the hot mix production. The first line gives you the monthly production to the tune of say 4,000, 8,000, 9,000, 16,000, and then in the month of September it is just 1,600 metric tons. So 1,600 metric tons. So for producing such quantities, the average fuel consumption per metric ton when you are keeping your mixed temperature from 160 to 165 is in the range of 7.8, 8.1, 5.3, 5.2, 5.4, 4.6. Again, these values are depending upon the other factors like how the aggregates are being stored and how the aggregates are being introduced into the hot mix plant. In this particular case, the variation is mainly because of the moisture in the aggregate, because the aggregates are stored in open areas, and this is an area which is prone for high rainfall. And the immediately after the rainfall, if you are using these aggregates, the maximum fuel is consumed to dry down the aggregate first to the extent possible. But in such cases, the average diesel or the fuel consumption to produce per metric ton of the hot mix was close to 6.5 liters, whereas in case of a hot mix asphalt under similar conditions, if used, it is in the range of 8.7, and this 8.7 was arrived at an average of 2 months production earlier in the initial phase when the warm mix asphalt was not fully established. That gives you an indication that there is a reduction of more than 2 liters per metric ton of production of asphalt. And if you remember, currently the fuel cost is close to 100 rupees. And if you are able to save 2 liters per metric ton production of asphalt, you are saving 200 rupees per metric ton of asphalt in the process. And if you are able to save 200 rupees per metric ton, see the overall quantity required in the project and see the quantity or the amount of saving which you are able to do in a particular project. So this is a brief indicator. In any case, this is one parameter which is helping you, which is giving you the direct impact in terms of the cost to the organizations as well as the government to understand if you are using the warm mix asphalt, if you are changing the technology from hot mix to warm mix, you are saving on fuel cost, you are saving on the rolling cost, you are saving on the transportation cost, and also you are saving on the other parameters, because once you are reducing the production temperature, you are able to increase the productivity of the mixes, and in the process you are reducing the running time of the hot mix plant. So all these direct and indirect costs, if you consider, your potential saving can be established by using a warm mix asphalt in place of a hot mix asphalt. And at the same time, you have an impact on the carbon footprint also, because since there is a saving in the fuel like gas or diesels, you can see the per liter saving will have an impact of 2.6 ton CO2 per liter as far as IRC SP 133 is concerned. And if you are able to save 2 liters per metric ton production, you are able to save huge quantity of CO2 emission in the project. So this is a direct indicator of an effort being taken by the industry for the sustainable construction. So this will give you an idea. Warm mix asphalt, the change in technology basically having a larger impact as compared to the change of material. Change of material happens, change of material is required, but change of material gives you more effort but less values as compared to change of technologies. So if you are able to see the potential benefits of a technology, all you need to do is to do a cost benefit analysis in terms of cost, in terms of sustainability, in terms of environmental benefits, and then you will be in a position to conclude whether the construction is sustainable in nature or you are just doing a saving in the cost and the CO2 emissions. So if you see a construction site, like the laying temperature here is 133, and the beauty is the lead time is generally, in this particular case, the lead time was close to 1 hour. Even after 1 hour, whatever the production temperature was, it was close to that, and it took time to reduce the mixed temperature. And ultimately what happened is your number of hot mix plants required for a given project can be eliminated. Like for a 60-kilometer road, normally we prefer to have 2 hot mix plants, because generally 1 hot mix plant covers a lead of 15 to 20 kilometers, and in terms of timing, if you see, it is close to 2 hours, 2.5 hours, because in the construction phase, even a travel of 15 kilometers will take more than 2.5 hours. So what happens basically is with one single plant, you will be able to cover the complete project of 60 kilometers if you are opting for a hot mix plant with a warm mix technology rather than going for a hot mix technology. So with that, I conclude my presentation, and the forum is open for queries and questions, if any. So, yeah. Hello. Professor Das? Hello. Mausami?
Hello, sir.
Yeah.
Hello,
I
sir.
had just finished my presentation, so you can open the forum for question answers, if any, and I'll be glad to answer those things.
So, anyone having any doubt, you can ask now.
If any participant has any doubts, they can ask question, put question to our sir. Any question from the participant side? I think there is no question.
No problem. Thank you, sir. Thank you very much.
Okay. So we have concluded our last session delivered by Professor Dr. P. Guru Raju sir. It was very informative, and also I think the participants have gained maximum knowledge from this Atal FDP program, and your session, both the sessions are truly speaking, both the sessions are outstanding sessions.
Thank you.
So,
thank you.
as there is no question from the participant side, it is understood that they have understood everything what you have delivered. So,
Okay.
with your kind permission, we want to close this session, sir.
Yeah, please. Thank you very much. We'll be in touch.
Okay. Thank you, sir. Good night, sir. Namaskar, sir.
Good night. Namaskar.